Whose lang is it? It's Erlang. Funny joke. Hello, everyone, and welcome to yet another recreation programming session with Mr. Azuzi. So for the past 2 days, I've been programming in Erlang, right? So for whatever reason, I just felt like programming in Erlang, probably because somebody mentioned it in our Discord server. And I heard about Erlang for a very long time, honestly, since I ever started programming, right? So I think I started programming in 2006 or 2007 or something like that, right? And since then, I heard vaguely about Erlang. At some point, I got into functional programming, and I looked deeper into this language, and through that language, I learned about actor models, right? So and the knowledge of actor models was actually extremely useful then later when I was programming professionally in Scala, because Scala has a library that implements actor models that are similar to Erlang. It's called Akka. I'm not sure if it's still used today, right? So has anyone heard about this thing, right? So is it still used, or is it a dead technology, right? So I can't can't really find much, right? It's a third link even on DuckDuckGo, right? So that's how fucking dead all of that is. But anyway, who fucking cares? Nobody gives a fuck. So yeah, so I developed a very simple chat service in Erlang off screen, just to refresh my knowledge of Erlang. So I think I even deployed it on your mom. Just a second. So maybe we can even start it up just to test it out. So I'm gonna SSH into your mom. Right. So here it is. We already kind of tested it offline. So somewhere here, I think it's in a Git. So Erlang chat. So here it is. So this is a very simple service, right? So this is how it looks like. So there's around, I think, 116 lines of code. Can we actually set a color theme to something more reasonable? Yeah, so Habermax is a little bit better. So something like this. And the way you do that, so Erlang is a virtual machine, right? So it's a dynamic, managed language, right? So it's not a native compiled language, it's a dynamic managed language. Because it's designed for this big dynamic enterprise system, for telecom systems. In fact, I think Erlang is the ultimate slop language. Right. Yeah, it is a slop language. So people say in the chat, I think it's the sloppiest language out there. It's the most sloppiest language out there. So it has this idea of let it fail, right? So it has this idea of let it fail because it relies a lot on these green threads that communicate with each other with messages, right? So you're constantly sending messages, and it's all very much dynamically typed. And the usual philosophy of handling errors that happen in threads that kill the thread is to have a supervisor on that thread that looks whether the thread dies or not, and then just restart it. So it's just it's a whole philosophy of let it fail. So it has a system of supervisors and stuff like that, and it's just don't handle any of that errors. An error happened, kill the thread, log the error, restart the whole thing, and continue serving the users. This is the ultimate slop mentality. It is the sloppiest shit I've ever seen in my entire life, and that kind of makes Erlang unique in that regard, right? So there's a lot of slop languages, but I think Erlang wins them all with this let it fail philosophy. Sounds based. Yeah, it is so fucking sloppy, it's actually based. That's how fucking sloppy it is. Right. So, because they don't just being half slop or halfway slop. No. If you want to be slop, be slop the full way. Bring it to the fucking logical conclusion. And there you go, you become based, you become Erlang, essentially. Embrace the slop. Yeah, it's a language that embraces the slop. And I fucking respect that. So anyway, so we have to actually start the shell, the Erlang shell. So I have this kind of thing, so it's going to be OTP and ERL. So this is how we do that. So there we go. So the first thing we have to do, we have to actually compile the main module, So, what is going on? Why can't I type M? There we go. So, and within that main module, we have actually start function, which actually starts 2 threads, right? Which actually starts 2 threads. And so as far as I know, people people already joining the chat. So some people already know how to join the chat. So yeah, so essentially this is the IP. And you have to actually telnet into that IP on the port 6969. You have to provide your nickname, Soding, and you can say hi. And somebody can say hi back to you. And maybe you can even get hacked. Right, so because I do not filter out escape sequences. Right, I do not filter out escape sequences. Right, so that's how we do that. So that's the service that I developed off screen just to test out Erlang, and it's actually kind of cool. It's actually kind of easy to do this kind of thing. So let's actually kill all of that. Anyway, so this is not what we're going to be developing today. This is not what we're going to be developing today because it's already developed, right? There is nothing interesting in here. So I just developed it to test out like how to create sockets, how to communicate and stuff like that, just to get an idea of what Erlang is capable of. And it's quite a capable language, right? So, and it was rather easy to develop this entire thing. It's like 100 lines of code. Really pleasant, honestly, really pleasant. So what I want to develop today instead is rather interesting. It is rather interesting. I want to develop something similar to pastebin service, right? So I want to develop something similar to pastebin service, but it's going to be also over telnet. It's going to be also over telnet. So the idea is the following, right? So you telnet pastebin, maybe it's going to be pastebin. So you telnet into the IP and the port. Right, and then you actually start with like a text protocol, right? You issue command something like post, right? Like you say, I want to post a particular text. Then you provide text of the, basically lines of the text, right? So here it comes line, 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 line. You type all of that in, and then you do submit. So, and here, I want to try out something that I heard about for a very long time. I want to try out the concept of a proof of work. So to prevent spamming, I want the server to challenge you, right, with a proof of work before accepting your submission. So who knows what is a proof of work? Proof of work. So this is something that is used in basically in cryptocurrencies, in blockchains generally, right? So in blockchains, and we want to use a variant of a hash cache, right? So, and essentially, hash cache was invented to specifically prevent email spam. So essentially, you're like, I don't remember, I think you're just given like some sort of a piece of text, and you're supposed to come up with a prefix that when concatenated with that piece of text, and then hashed with SHA-256 or some other hash function, it has a trailing or leading n zeros in it, right? So the thing about this challenge is that it is very difficult to solve it, right? So the only way to solve that challenge is to randomly try different prefixes, right? And you're gonna spend like a certain amount of compute doing so. But at the same time, it is easy for the server to verify that you, finish the challenge, right? So that you fulfilled the challenge. So it's very easy, difficult to do, but very easy to verify. So, and this is something that I want to try to prevent people from spamming too much stuff into this pastebin service, right? So after you do submit, the server sends you something like challenge, and it may be going to send you like a random string in there. So the idea is, what you're supposed to do, you're supposed to take your text, then concatenate it with the challenge string. And then you're supposed to come up with some sort of a suffix when concatenated with the text you posted and the string provided by the server, and also with the suffix, right? So concatenate all that together. Hash will contain certain amount of leading zeros. And then you basically submit back that suffix after some time, after you find it, with maybe accept it, right? So it's kind of funny, right? So the server sends you challenge and you say accept it, right? And then the server will tell you maybe sent and gives you the ID of that specific file. It gives you the ID of that specific file, right? So after that, right, so if you want to receive that file on the other end, you telnet into IP with a particular port and you say get that ID. So there's two main commands: post, and after doing post you do all of that stuff, and then you do get and you get the ID. Right, so the reason why the protocol is designed like that is so it's easy to create a script that will do all of that stuff for you automatically. Right, so it's very easy for you going to be create like a Python script, which you have a text file, right? So, and you call your Python script with that text file and it do all of that for you automatically. It, you know, passes the challenge and stuff like that and gives you the ID. So that's basically the idea behind this service. And I want to develop this service in Erlang, right? So, so proof of work is actually used extensively in something like Anubis these days, right? So, do you guys know about Anubis? So proof of work. How can I find it? Yeah, so this thing. Essentially, it's a thing that was created for open source projects to protect them from AI crawlers, right? Because the AI crawlers, they basically DDoS all of the open source projects. So essentially, to prevent that, what they do before entering a website for open source development, right? So you have to pass a certain proof of work, right? So, and that puts a lot of too much cost on AI crawlers, right? So because they have to use a lot of compute just to scrape all of this website. So the idea is that it's going to become so expensive that they're going to cease doing so. Anubis is malware according to FSF. Who fucking listens to FSF? Anyways, so yeah, that's what we're going to be doing today. We're going to try to do that in Erlang. So I think I'm going to maybe put all of those links in the description, right? So this is what we're going to be doing today. So this is a proof of work, this is a hash cache, and this is Anubis, right? So this is Anubis. So yeah, thank you for all of the subs. Thank you. All right, so let's go ahead and maybe create some sort of a folder. So how I'm gonna call it? Paste bin. Wait. What a funny name! Holy shit! Paste bin. Yeah, banger name. So, by the way, I think I don't have Erlang installed on this specific account, on this specific machine, right? So, oh yeah, we'll probably have to like build Erlang from scratch. So, like, I'm building Erlang from scratch because it's actually super easy, and I'm gonna be probably using functions that are only available in the latest Erlang, right? So this is something that I encountered while developing in Erlang off screen. Right, and so it's just like it's easier to use the latest one built from scratch, right? So let's go somewhere here, and I'm gonna wget this entire thing. So might as well, yeah. So we're gonna do a little bit of a building stream, How about that? It's not that difficult, by the way, right? So it's super easy and it's super fast. Erlang by itself is rather simple language, right? So in terms of like implementation, right? So let's do something like that. OTP, let's fucking go. It uses auto tools, right? So just like a regular configure script, you know, classic configure stuff. So you can enable or disable certain components. And so the only thing we're going to set just the prefix, right? So this is going to be OTP 28, right? So just install this entire thing in there. So it's going to go through all of the checks and stuff like that. It's going to check your dependencies and maybe disable some of the components. So as far as I know, one component that is going to disable 100% is WX. So yeah, Erlang, funnily enough, Erlang comes with WX widgets bindings. Right, so there's this library, old GUI library, I don't know how many applications this day actually use this library. I think the biggest application that uses WX widgets is Audacity, right? So apart from that, I don't really know any other application that does so. So, and for some reason, for some whatever weird reason, Erlang comes with the bindings for this specific library, right? So it's kind of interesting. And as far as I know, yeah, WX widgets is not going to be actually built for this specific thing because I just like some libraries in there. Right, so but we don't really need that because we're developing like a web server, right? So it's not even a web server, it's just server. Let's just do the build, right, in 16 threads. And yeah, so while we're building, I don't think it's gonna take too long, but while we're building, KiCad, okay, so it's also using WX widgets. So yeah, it's building. As you can see, it is building things. Isn't that cool? I think that's pretty cool. I had a stream about Erlang in the past, but I was not programming directly in Erlang. That's the thing, right? So I was just messing with the Erlang virtual machine. But today I just wanna program directly in Erlang, right? So I'm kind of in a sloppy mood today, right? So I kind of like crave a little bit of a like sloppy language, you know, like a sloppy language. So yeah, and that's what we're gonna be doing today. Asm JIT. So there is a JIT compiler in Erlang apparently. That's very interesting. That is actually rather interesting. So what's your favorite slop language? I don't know. So the same thing with my favorite language in general. I hate them all equally. Okay, so let's install this Scheiße. It's going very fast. It's installed a lot of shit. There you go. It's finished installing. Okay, so let me see what we've got. So it's OTP28, and here is Erlang repo. So that's how easy it is. You just build it the usual Linux way, configure, make, install, and you get Erlang. Right. So, and if you need the latest Erlang, it's actually super easy to do so. So, all right. So we have to do something like this. So what's funny is that official Erlang comes with Emacs bindings. This is rather interesting. So because the developers of Erlang themselves, they use Emacs a lot. So in this installation folder, there should be some Emacs bindings. I think I saw them, but let's actually do find name Emacs like this. So here it is. So here is the Emacs tooling. And yeah, so here's all of the Emacs stuff. So do they have instructions on how to install it? Yeah, so you have to add, you know, this folder to the load path. And so set Erlang root dir to that specific thing, and you set exe path. Okay, so let's actually go ahead and do that. All right, I think it's a cool idea. We could have installed. I think this Erlang module is also available on Melpa, which is a repository of Emacs packages. But we can try to actually use it like this. I'm rather curious. I never used it like that, by the way. So when I was programming Erlang off screen, I just used the Erlang extension that comes from Alpa, but I'm kind of curious, like how easy it is to use the one that comes with the installation, with the source code of Erlang. So I'm really curious. So here it is, and here can I just use, you know, OTP, then something OPT. It's actually OPT, OTP28. Right, so and in here, this is basically lib tools version. Okay, so let me go maybe somewhere here. Yeah, this is what we want to do like that. So this is the lib, boom. Okay, so we just added that to the load path. This is a really weird way to append something to load path. I think there was add to list function. Right, so usually when you want to, yeah, so usually when you want to add something to the list, you just do it like that, load path, and you just add it like that. So Erlang developers are a little bit weird like that, but I mean, that's fine. So, and in here, it's just like Erlang root dir. I suppose this is where we have to set this thing. I really hope like that putting tilde in here will actually pick it up, right? I'm not 100% sure, but I hope so. And here is an execution path. Let's actually set the execution path somewhere here. So when this is going to be something like bin. But again, I could have just used add to list to add this entire thing like that. So no need to do it in this weird way. So then you require Erlang start. Actually, we don't have to restart Emacs. I can just do it like that, then like that, then like that, and then it say require Erlang start. Okay, so that seems to be working. So now paste beam, right? So let's actually have something like main Erl, right? So here's the main Erl, and I suppose we can just write some sort of a hello. Okay, that already, like, it already picked up an Erlang extension, but maybe I already had Erlang extension installed. That's kind of interesting. So that could be a thing, I believe. So the easiest way to check that is to maybe go to Alpa in here. No, I don't have it. I think it picked up the extension from the installation in here. Okay, so let's actually do something like format hello world, right, like so, and let's try to maybe even compile the whole thing. All right, so yeah, the first thing you have to do, you have to define a module, right? So all of the functions are located within the module. You usually call the module the same way as you call the file, right? So, and another thing, I think you have to export the function like this. So this is a signature of the function. This is a signature of the function. Erlang is a dynamic language. It is a dynamic language. It doesn't have a type associated with it, but it distinguishes functions by their arity. So, and a signature of the function is essentially name / its arity, which is the amount of arguments. Right, so since this function accepts 0 amount of arguments, the arity is 0, and you basically say, okay, so this is the function that I exported. So if I do something like main x, and so then x plus 1, right, so this function is not going to be exported because it's a different function, which is a main /1, right? So it basically overloads functions like that, and it distinguishes them by the amount of arguments they accept, right? So, and what do we have in here? Syntax before main, I forgot the dot in here. There we go. So it's successfully compiled. And now if I want to call main from the module main, I do it like that. And there you go, hello world. And that's how you basically create all of that stuff. So it's a dynamic language. You can think about Erlang as a scripting language. So there is no exe in here in any way. But at the same time, there is a beam file, right? So your Erl files usually compile to beam files, and as far as I know, I think you can even remove this entire thing in here, right? You can literally remove and just have a beam file. And if you go into the same folder, where you have a beam file, I think you will be able to actually load this beam file, right? There's no source code. We just deleted the source code, right? So I'm going to go into OTP bin Erl, and then I'm going to say, okay, load this thing. Yeah, and I managed to load this entire thing, and then I call this entire function. So you can actually kind of distribute Erlang programs without the source code, even though it's a dynamic language, if you have these beam files, right? So that's kind of the binaries, the final binaries. So yeah, beam is like a bytecode, like a class for Java. So I think it's closer to Java, but at the same time, Java is more of a static language. No, not really. I think Java is also kind of a dynamic language. The compiler statically checks the types, but the runtime itself is actually very much dynamic because it allows you to dynamically load and unload classes, and I think it even has an error related to dynamic casting and stuff like that, right? So it's just like it's closer to Java. It is in fact closer to Java, right? But anyway, so let's actually quit this entire stuff. We don't really need that. So it's kind of like the thing that annoys me about this REPL is that to quit the REPL, you have to type this function, and the funny thing is that it doesn't quit instantly. It prints you the next prompt, which makes you feel like it didn't do anything, and then after a second it quits. Like such a fucking weird UX. Is like I'm pretty sure there is a good technical reason for it to behave like that, but holy fuck, from the user point of view, it's so fucking weird. Anyways, slope, yeah, it's a slope quit. Like, I've never even seen anything like that. Like, you could have at least told the user quitting. Right. If you can't quit immediately because you're shutting down the services because you are slop like that, you could have at least told this the user, okay, I'm quitting, please wait. Right. Like, it's some sort of like a hat, right? I'm sloppy language, please be patient. So anyways, so let's actually remove all that stuff. Earl. And so we need to actually, you know, create a TCP server, right? Create a TCP server. And as far as I know, the main module for working with TCP and stuff like that is called GenTCP, right? So this is the main module that we need in here, GenTCP. So yeah, so let's actually have something like module. This is a main. Maybe I'm gonna actually call it pastebin, right? And oh, module doesn't match file name, modify source. This shit's coming from the extension for Erlang, for Emacs. That is very fascinating. So you have like a file name, right? You try to change the module, you try to save it. The extension prevents you from doing that, right? And you can say change it back. Clippy as extension. Yeah, I do agree with that. So the way to change that, pastebin, right? So I renamed the name and then I maybe modify some stuff and now it changes. So like you have to do that the other way around, right? You do that the other way around. You change the file name and then you try to save it and it will change module for you. Anyways, right. So let's create some sort of a function which starts the server, right? So we have to do GenTCP, and so we want to actually start listening. This is not what I want. Start listening to a particular port and whatnot. So as far as I know, the thing that I discovered while working with Erlang is that you have a function, Erlang man function, right? So you can inspect the documentation for certain functions and stuff like that. So manual entry, yeah. So find that. And what's interesting is that by default, the manual pages of Erlang are not available. Extension allows you to download them from the official website, right? So there you go. So you can automatically download all of that stuff in here. So let's go ahead and download the man pages. There we go. So it was rather quick. It downloaded the man pages, and now like this is literal man pages. We can like inspect all of that stuff in here, if you're interested. So here's the thing. So they also tell you the signature of the function, even though there is no types in Erlang, there is specs. So you can kind of have like optional specs on dynamic functions that document what kind of types functions expect and what kind of things they actually return, right? And none of that is really checked, right? It's akin to Python types, like MyPy and so on and so forth. Do you guys know about MyPy? MyPy. Right, so you can have like Java docs. It's not really a Java docs, it's closer to Python types, right? So I'm specifically talking about Python types, right, because they're not like Java docs. So, and like closer thing would be TypeScript probably, right? So, and they're not checked, they checked by external tools like Dialyzer and stuff like that. Right, so, but they're useful for documentation purposes. They're really useful for documentation purposes. Okay, so what we need to do, we have to provide the port, right? So it's going to be 6969, and then we have to provide options, and options is a array or list of listen options, right? So to know what is a listen option, I think, yeah, so you have to search for listen option, and here are listen options, right? So, all right, so in here, what we have to do in here, I don't quite remember. So we can just try to, one of the things I probably want to do, so is to do reuse address. It's not particularly available. I think it is available somewhere in here. Man, can I just do man function? Yeah, address family, but this is, yeah, this is not what I want. So maybe what I'm interested in is this option. Because I remember there was a reuse, yeah, here it is. So it's an option name. And option name is used in where? Okay, so again, TCP example. I forgot how to use this thing. I used it yesterday, but I already forgot how to use it. So there was some example. Yeah, there you go. This is how we use it. So you provide the port and you provide the binary. I was hoping that maybe I could figure out all of that stuff through the signatures, but I completely failed. Right, so one thing you have to do, you have to provide binary saying that this is a binary protocol or something like that. I'm not quite sure, like if they, yeah, so there was example in here apparently, yeah. So packet 0, okay, so I don't really know what all of that means, but so let's just go ahead and copy paste this entire thing. And one thing I'm interested in is probably reuse address as well, right? So because when your connection dies, right? So when your connection dies, you want to be able to just like reuse the same address over and over again. So this is something that TCP sockets don't do for you automatically for some reason. Okay, so and when you do that, you get a tuple. You get a tuple that returns the first element is okay, and then the listen socket, right? So the listen socket. So essentially, this is what it returns to you. It returns you a tuple. And what we're doing in here by doing equal, we're pattern matching or we're destructurizing the result. Here's an interesting thing. The case in Erlang actually matters. The case in Erlang actually matters. So lowercase is atom, which is like symbol in Lisp, right? So by themselves, they just have like a value of their own, right? So if, for example, I say hello, the result is hello. It's a symbol, not a string, but a symbol that is equal to itself. It's just a symbol. It's a symbolic language, again, similar to Lisp, right? So, but then if you type it like that, it will say that variable hello is unbound. You distinguish variables and symbols by their case, right? So, and it's kind of not a new idea. Prolog does like that. And in fact, Prolog is like inspired syntax of Erlang. So as far as I know, Ericsson, the company that originally developed Erlang, they used Prolog for their needs, right? And then they realized that Prolog is not perfect language for what they're doing, and they developed a new language, Erlang, right? So which kind of retained the vibe of the Prolog syntax, right? So maybe it's kind of similar to symbol in JavaScript. Yeah, it's kind of similar to symbol JavaScript. If you want to have a symbol that has like literally this kind of name, I think you can use single quotes, and that is basically the symbol like with any casing, right? So without the quotes, right, this is a variable and this is a symbol, or they're called atoms in Erlang. Right, so essentially the way Erlang functions indicate error, they usually return you an OK symbol indicating that everything okay, or if you want to return OK plus some sort of a result, it's a tuple. Tuples are with curly braces, right? So you basically can have like 69 or hello, and this is a tuple, right? So at any point you can actually destructurize and bind this entire stuff like this, right? So then you can have X and Y. That's how it works, right? So it's a functional language, right? It has a quirky syntax, but at its core, it's a classical functional language akin to Haskell, akin to Rust. You do stuff like that in Rust all the time, for instance, right? So you also have tuples, you can pattern matching, you can like bind the variables and stuff like that. That's what it is. That's what it is. And the idea in here is that on success, GenTCP listen will return you a pair OK plus the socket. You match that it is OK and instantly bind the socket to this variable, so then you can use it. That's the idea in here. If the operation fails, this pattern won't match, so the interpreter will fail. That's the idea. So this doing something like that is akin to unwrapping in Rust, right? So you just straight up pattern matching, and if it doesn't match, that means an error happened and the execution will stop, right? So the execution will stop. If you want to handle errors, right? So the way you can do that, you can just basically switch case on this entire thing. Right, so we need to see what exactly does it return, right? It either returns pair OK and listen socket, or it returns pair error, which is also a symbol with the reason. So the way you can handle this kind of stuff, you can do case off, right? And in here, if it's OK, right, you do something, right? So do something like this. And if it's an error, right, you can do a reason, you can log that reason. You can do stuff like that, right? So error, and you can provide stuff like this, and this is the reason, and then you can close this entire stuff. If you really want to handle this entire stuff, but we don't really want to handle any of that stuff, right? So we're going to just basically unwrap this entire thing. Because if we couldn't listen on this particular port, like what's the point anyway? What's the point? There's no point. So anyway, so we start listening, and after we start listening, we can start accepting things. We have to do gen TCP accept. Notice how, so the sort of statements in here are separated by commas, right? This is because there's no really statements in here. There's only like expressions, right? So, and a function, right? So a particular function is basically expression 1, comma, expression 2, expression 3, dot. Right, and what's happening in here is that it evaluates expressions in this specific order, and then the result of the function is the last expression. So that's what's going on in here. That's what's going on in here. So in some of the expressions may introduce like new variables and stuff like that. So this is the first expression, right? So then this is the second expression that we're typing in here, right? It's a sequence of expressions, So, so we need to do accept. Let's see what is going on in here. So we have to provide the socket, le socket. And what it does, essentially, it returns you either like OK or error, and then it returns the socket of the connection. So that means somebody has connected. So after that, we can maybe send something to the user, right? So send, where's the function? Yeah. So send socket, and we can send them something. Can we send them string hello? Right, I wonder if we can send the string hello in there. And after that, we can do gen close. It's actually gen TCP send, then gen TCP close, and we're closing the socket. Right, so that's how we organize all that. Does it compile? Seems to be compiling, right? So, but complains that start is not used anywhere because it's not exported out of the module, right? So this is going to be start 0 like this, and there we go. So I wonder if I can do something like start. All right, so undefined function. Oh, it's because it's not main; it's a paste. Okay, paste bin start. So can we start this in that? Okay, so it is waiting for something. It is waiting for something. Telnet localhost 6969. Right. So and we got hello. So yeah. So it just has a built-in convenient library for TCP. It's a very convenient. It's a very convenient library. So that's kind of cool. That is kind of cool. But it does this thing only like one time. Right, it does this thing only one time, which is not particularly convenient. So we want to kind of do that in a loop, but unfortunately, there's no loops in Erlang at all because it's a functional programming language, and loops are for imperative plebs. What you're supposed to do, you're supposed to use a recursion, right? So essentially, we may maybe introduce some sort of example, right? So you can have X. Which is going to be a number. Let's say that it's going to be a number. And what we're going to do, we're going to do format, right, so something like this, and it prints X. And then we recursively call X minus 1. So as far as I know, in here, you can accept X, and you can have like sort of guards. If X is less or equal than 0, right, so we can say, maybe so say something like just return OK, right? So just return OK. Otherwise keep printing and decrementing 1, right? So that's how we do all of that, and we want to actually export this entire thing. So as you can see, we accept 1 argument, so because of that, it's a loop 1, right? And it's not how we do that. So is it something like that? Yeah, it's probably. Less than equal is an arrow to the left, and because of that, it is reserved in Erlang, and you have to. Nice language you got there, Erlang. Ericsson. Anyways, so let's actually see. So it's a paste bin loop 10. and not a list. What the fuck are you saying? Okay, so you know how printf in C and any other languages is actually variadic? Well, there's no variadics in Erlang. There's no variadics in Erlang. But you still want to accept a variable amount of arguments. Okay, the way you do that, you're actually supposed to put a list in here. You see what I mean? You see what I mean? So then you can have several of them because it doesn't support variadics. It's just like, I mean, it's kind of funny. Yeah, so I think it even says that, yeah, I think it even says that somewhere here. So format data, right? So, and if you take a look at the type of the data, yeah. So the type of the data is a list of terms, and term is basically an expression in Erlang. It's kind of interesting. So Erlang calls symbols atoms and expressions terms. And I think term is a term from mathematical logic. Right, so it's just like logicians, math logicians usually call expressions terms, right? So they have their own vocabulary regarding all of that stuff. So yeah, it's supposed to be like that. And now if I do paste bin, there we go. It just loops from 10 to 1. And when it reaches 0, it says, okay, because this is the atom that we returned in here. So this is how you organize the loops. And what's interesting is that in here, it's not going to overflow the stack because it's a tail call optimized recursion, meaning that if the last term is basically called to the function, it doesn't really perform the call, it doesn't push a frame onto the stack, it just reuses the same frame that is on the stack, so it doesn't blow up the stack. So that's how it is organized in functional programming languages. It is kind of different than Haskell because Haskell doesn't have a stack, and in fact, the model of computation in Haskell is completely different, right? So because it has to be lazy, but this language is not lazy, right? So because of that, it does have stack, and to not blow it up, it uses tail call optimization. So that's how it works. And if you want to continuously accept connections, you probably have to organize something like that. This entire shit can be infinite, by the way, right? So who said it can't be infinite? You can do some shit like that. And this is an infinite loop, and it's not gonna stack overflow at all, right? So we can try to do something like this, right? So just prints indefinitely, right? So we want to abort this entire shit because fuck that. But anyway, so we want to organize an infinite loop. So let's maybe have some sort of a separate function that is going to be called acceptor, right? So acceptor, and it's going to maybe accept socket, right? So there we go. And we want to move this entire shit into the acceptor. So then after we served the request, we just repeat that again, right? And after the start, we say acceptor sock, like so. This is what we got. What's interesting is that we don't really have to export acceptor, right? So it could be purely like an internal one. It could be purely an internal function. So let's actually go ahead and see what we have in here and paste bin start, right? As you can see, it has started. And then we can do telnet, and it says hello. It's kind of annoying that it doesn't say like a new line, so it's kind of difficult to see. So let's try something else in here, right? So we have to always kill this entire thing. So let's put a new line in here. Maybe on top of that, it would be nice to have some lines like so. So we have some lines like this. Does it compile? It seems to be compiling. So if I remember correctly, you could actually split the string literals like this. I feel like this is something that you can do. So then you can actually put them like that. It's kind of similar to C, but don't quote me on that because I do not remember. I think you should be, yeah, you can do that. It's like, yeah. So this is rather convenient. So it's still going to be considered like a single string literal. So Erlang, mind you, is a very old language. So it's a very old language. So, and because of that, it may be like inherits some ideas from like languages like C. All right, so let's fucking go. So what do we have in here? And yeah, so if I just do not really loop, but start, there we go. And in here, it's going to be telnet. Let's go in here. It says hello, and I can do that multiple times, right? Because it loops. So as you can see, it in fact loops. It's pretty cool. It's pretty cool. But one thing that is happening in here is that it kind of blocks the REPL in here, right? So we have to like kill it. So I think the time has come to introduce maybe the Erlang processes. What I want to do, I want to actually keep acceptor in a separate process, right? So in a separate process, because that's kind of the whole point of Erlang. The whole point of Erlang is multiprocessing because it's a concurrent language and stuff like that. And to do that, we have to use this spawn function, right? So it's located in module Erlang. Right, so Erlang spawn. So let's take a look at that. So is it? Yeah, there we go. So what you're doing here is that you provide a function. You provide a function and it returns you a PID. It returns you basically PID. And this is something that we probably can try to do in here. Right, so in the function, yeah, so as you can see, you have to provide a function that doesn't accept any arguments, but our function that I want to keep in a separate thread, specifically acceptor, accepts one argument in here. So because of that, we need a different variant of spawn, probably this one. It accepts a module of the function name, and arguments as a list, right? So as you can see, arguments is a list of terms. Right, and it returns you PID. And you can do all sorts of things with PID. For example, you can send a message to that PID because Erlang communicates through sending messages to different threads. Right, it's kind of similar to Go, right? So, and then in Erlang, there is a construction called like receive, which allows you to pattern match on the messages that you received. Right. So let's actually go ahead and try to spawn maybe acceptor, you know. So the module that we have in here is a pastebin, and then this is acceptor, and the arguments we're going to submit in here is going to be lsock. Right, so this is going to be lsock. And we could maybe assign PID to some variable, but let's actually just return it to the user. Right, so what that means is that this particular function is going to be looping in a separate thread, and the user who called start, they will have a PID of this entire thing, right? So, and then they will be able to maybe send some messages to this acceptor, or maybe kill that acceptor, right? So let's actually try to compile this entire thing, and it's not going to compile, right? So because this function is not used anywhere. Right, even though we kind of directly spawned this function, it is not really used anywhere. So if I understood correctly, this is because we never really referred to this function anywhere by calling it, or we never really, you know, mentioned its signature anywhere. And spawn is located in a separate module. So for spawn to be able to start a new thread and call this function has to be visible to spawn from a different module. So because of that, even though you don't really call this function directly outside, spawn calls this function from the outside. So you have to export it. If I understood correctly, I think this is what's going on in here. Right, and after that, it will not complain that this function is unused, right? So after that, it compiled successfully. Right, anyway, so now we can do paste beam, and we can start this entire thing, and let's actually assign PID to that, right? So there you go. So we can still do things in here, right? So we have a variable that is called PID, and at the same time, I can do this kind of stuff. Right, and I still have the REPL in here. So, and at any point, I think I can just do exit PID, and I can kill the entire thread. So, and error in a process, so it errored in this specific PID. So the value of PID was that, right, and an error happened within the PID, right, and I think, yeah, so it failed in the acceptor. Right, it failed in the acceptor at the line 9. Okay, so I suppose what happened when the main thread of the REPL sent an exit sort of signal or exit request to the thread, so this accept failed and this matched failed, right? Because it got interrupted probably, right? So because as far as I know, accept blocks and waits, and as soon as you received some sort of an interrupt or some sort of a signal, I don't really know how exactly Erlang, you know, tells the threads to shut the fuck up. But something happened and this thing got unblocked and returned an error instead of OK, and that killed the entire thing. So That's basically what's happened. So it's kind of convenient to keep this acceptor in a separate thread, so we still have an access. We still have an access to this entire thing, and can communicate with it and stuff like that. So it would be kind of cool to maybe even send some information to the speed. For example, maybe quit yourself or change the message, right? So that would be kind of cool. So we can try that. So we can actually try that. So let me actually think. So what we can do in here is that in the acceptor, we can accept the message, right? And as we loop in here, we also loop with the message. And maybe we're gonna actually put the message in here somewhere, but to be able to do that, we need to format the string. So if I remember correctly, the thing that I used was IOLib format. So let me take a look at the function of this entire stuff. So IOLib function. Yeah, there we go. So it's almost like IO format. So IO format just prints the formatted string onto the std out, but IO format returns the formatted string. So let me actually see. So if I do something like that, so this is going to be this, then I'm going to say this is the message, this is the string, and this is new line, and here we have hello. Yeah, so it's the same shit. There we go. Very interesting. So, well, I mean, it returned a string, yeah, and a string in Erlang is a list of characters, right? So, but then this thing is a separate string in here. So the strings in Erlang are kind of complicated. So new line is an I thought. Well, it works both ways. It works both ways. Suppose /n is escaping on the level of a string literal, and %n is escaping on the level of the format function, I think. Right, so I think that's how how it goes, but whatever. Anyways, so what I want to do in here is probably use IOLib. I'm gonna say format, right? So we got this entire thing. And in here, I wonder if what if I just have a list of these things? If I, for example, have a list foo bar, right? So this is that. Because I know that some of the Erlang functions, they actually accept the list of strings and actually send them properly, and they flatten them out and stuff like that. I wonder if I can do shit like that and it will still kind of work. Like, I'm really curious if it's going to work. Like, because of that, we don't really need format in here, right? So we can try to do it like that. So this is what I'm sending to you, right? So as a single stuff. So acceptor, yeah, so it accepts. So message, yeah, let's remove the whole thing in here. So this is going to be that. And if I try to, right, where's what pid? Pastebin, so this is going to be something like that. And yeah, it didn't work because it's already started. Okay, so can I do it? Yeah, telnet. Okay, so I can actually give you the list of strings, and it will automatically flatten it out and send appropriately. Okay, that's pretty convenient, which means I don't really need to use formatting that much. I can just have a message in here and just put message in here like that, maybe with like a new line and everything, and I can keep forwarding the message in here. Right, so, and I should not forget now to put message hello like that, because it's a dynamic language. It's not going to check that stuff for me automatically at all. Right, so, and what I want to be able to do is that whoever called this function, I want to be able to tell this thread, go change your message. Right, I want to be able to do, like, to say, go change your message. So the way you do that, by the way, is that you do receive, and receive acts like a switch case. Receive acts like a switch case, and in here you can pattern match upon different like terms or different expressions. So we can come up with like some sort of format. Let's say if the user who started this entire thread sends something like message, new message, we're changing the message that we're serving to the user. Okay, when somebody sends a message to the thread, when somebody sends the message to the thread, right, so we're gonna be specifically expecting, tuple message with a string, right? So tuple message from the string. And if we receive something like that, so essentially what we have to probably do is that we have to call acceptor with a new message now. So, and specifically in here, we're gonna call it new message, right? So it doesn't collide or doesn't shadow this specific thing in here. So this is a new message. So it's gonna be lsock new message, right? So, but here is an interesting thing, right? So it's kind of weird because this entire thing blocks, and we won't be able to do receive until it kind of unblocks. So we won't be able to do that. So I feel like because of that, we have to keep this acceptor. In maybe in a separate thread as well. All right, maybe that's what we have to do. Maybe we should have several threads in here. So one thread only accepts things, and yeah, that's a good idea. Let's actually try to refactor the whole thing. So acceptor is not going to be sending out the message. It's not going to be responsibility of the acceptor. So let's remove the message from here. So I don't really want to lose this code, so I'm going to put it in here. By the way, comments in Erlang are percents, right? Comments in Erlang are percents. Right, so let's keep all of that in a separate thread. What you gonna do about it? What you gonna do about it? Go to Erlang police? Erlang police cannot do shit. It's a threat now. It's a fucking threat now. Erlang police can't get me because I'm in the middle of Siberia. I'm not even joking. I'm literally in the middle of Siberia. Go get me. Go fucking get me. Can't do shit. Fucking threat. So I'm going to call Erlang police. It's a direct threat. Anyways, so essentially the idea is that acceptor, yeah, we need to have a PID of some other thread that sends out the message, right? So I don't really know. Let's call it something like sync, right? So sync is whoever we are sending that to. So an idea in here, right? The idea is in here is that you accept the connection, and you send that thing to that sync, right? So connected, and we say, okay, so this socket is connected. So this is how you send, by the way, messages, right? So you have a PID, and P in PID stands for thread. Right, so P in PID stands for thread. And so if you want to send a particular term to that thread, right, so this is how you do that. You use a P thread. You use this operator, right? So you use this operator. So now we're going to do something like this. And so this is how you kind of retain the state of your loop, right? This is how you retain the state of your loop. You just basically keep passing it over and over again. So yep, that's pretty cool. And now we need to have like separate thread. Let's call it server, right? So this is going to be the server. And I don't think we need to have any parameters in here, maybe accept the message, right? An acceptor should not have a message, right? It shouldn't have a message. So, and in here, right, so we are waiting for messages. We're waiting for messages. So the different messages that we can have in here is connected, right? And you like get the socket. So when you get the socket, what you do, you just do send, and we're sending out this specific message in here, right? So this is the line, like so, then the message, then the new line, and another line like that. There we go. And then we close that. Then we automatically close this entire thing. Right, and all of that in a separate thread. So we accept things in one thread, sending it to another thread, right? And in another thread, we're sending out the message and we're closing the socket, right? And we want to be able to change the message, right? We want to be able to change the message, right? Let's actually accept another thing. Let's call it message, and this is the new message. Right, so since we like accept connection, we want to continue looping, right? We want to continue looping, so we're gonna call server, but with the old message. But when somebody sets a new message, we continue looping, but with the new message. As you can see, all of that is recursive, right? And there you go. So we have two functions in here. One function is responsible for just accepting connections and forwarding that connections to this thread. And that thread is responsible for sending out the messages and also for listening to the main repo if the message needs to be changed. Right, if the message needs to be changed. But now what we have to do, we have to create both of the threads. Right, so we have to create both of the threads. So doing one single spawn is not enough. So in here we have acceptor, which accepts 2 arguments, and a server, which accepts 1 argument. So I suppose the first thing, since acceptor needs to have a sync, server has to be the first thread that we're creating here. So this is going to be server. And so we just put a message in here, right? So this is the message, and here is our sync. So and then in here we do spawn. So we spawn paste beam acceptor, and we put in here what? lsock and sync. Right, so and in here we kind of get the PID, but we don't really care about the PID of the acceptor, I think. So we can just like completely ignore that. And the only thing I care about is the sync. So I'm going to return that out of the start. Right, so does that, all of that compiles. All of that compiles. Right, so now what I can do in here, I can do paste beam start this entire thing, and I want to actually get PID. Yeah, so let's restart the whole thing. So this is going to be something like that. Okay, it has started. Now I should be able to do that, and as you can see, it says hello. Right, it says hello. Now from here I should be able to say, okay, message your mom. All right, I send to the server this specific message. I send it from repo. And according to this code, if it receives this kind of message, it should actually start looping with a completely different message. So now if I connect, it actually says your mom. So and all that is completely immutable, by the way. We don't have variables or anything like that. We only use like recursion and stuff like that. So now from the repo, you can kind of control these threads by sending different terms and stuff like that. Right. So, so this is basically how we can organize this entire stuff. Right, that's pretty cool. It's pretty cool. So it's kind of like also kind of cool to sort of like split the responsibility between different sort of processes and stuff like that. So this one is like localized, responsible only for accepting connections. This one is only responsible for sending out messages and stuff like that. So Discord uses Erlang as far as I know. They use all sorts of shit. Weren't they using also Rust? Or like, I don't know. So what's their stack? What's their stack? I don't remember. Right. They use a lot of things. Okay, so that's pretty cool. So yeah, we're already streaming for like 1 hour. I think the time has come to maybe do a little bit of a break. Because I want to make a cup of tea. So WhatsApp, yeah, I know that WhatsApp uses Erlang, but as far as I know, the reason why it uses Erlang is because it uses eJabberD, right? So which is a XMPP server which is written on Erlang, in Erlang. So yeah, So, and I mean, for this kind of stuff, I think Erlang is perfect because it was specifically designed for telecommunication purposes, right? And WhatsApp is basically a telecommunication, isn't it? I think it is telecommunication, so it kind of makes sense to use Erlang for this kind of stuff. Not just that, they were a full Erlang shop. Okay, that's interesting. So they stopped. Anyway, so let's make a small break, and I want to make a cup of tea, and after that we're gonna continue. Sounds good? Good shit. I'm good shit. We are back, my friend. Okay, so I got my tea, and I think we should start. Here's the thing. So we accept the connection, and now, so the user kind of goes into this mode where server keeps changing the state depending on what exactly is going on, right? So if you take a look at the spec that we created in here, right? So you do telnet, which you usually do in a terminal, right? So this is in a terminal, and then the user is supposed to send a post, right? So, and then they send a bunch of lines and stuff like that, and then they send submit. So as soon as you do telnet, when you connect, the server is waiting to know what exactly is the action that you want to perform. It's either it's a post or is it a get, right? Is it a post or is it a get? As soon as it receives either post or get, it switches to a different state, right? So if it's a post, it expects line and then it expects submit. Right, after submit, it enters another mode, right? So this is challenge, this is something that it sends to you. So by the way, I think it would be better to maybe change it to txt, right? So because it's not really markdown in here. So it sends the challenge, you send accepted back with the suffix, and it sends you back send, and then closes the connection, right? Connection closed. So that's what's going on in here. So that's basically the protocol. So, and as you can see, the server transitions through like various states in here. But what's interesting is that the server also has to maintain several connections, and each connection can be in its own separate state. So it's a state machine, but it's a n state machines. It's a n state machines. So what I'm thinking is that each individual connection is going to be its separate process, right? It's separate process that transitions between different like functions and stuff like that. Thread per connection, yeah. So it's probably going to be thread per connection. So yeah, we have an acceptor, which is responsible for accepting connections, and it's going to be sending out. Maybe it's not going to be even sending out the connections. It's the acceptor who's going to be responsible for creating these state machine threads. Any green threads in Erlang. I think any is not the correct word. I think all of them are green, aren't they? So, but maybe it utilizes some system threads to just like scale it a little bit better. I don't know. I don't know how exactly it works. Right, so, and here is just we get text. Right, so maybe we can even do something like that. So you get the line back, line, right? So this is how you send, and this is what you receive when you get the ID and the connection closes. So the very simple protocol, very easy to implement in my opinion. Right, so we don't even need to separate this kind of stuff. So this is our spec. We're gonna keep it like that. Okay, so here's the acceptor, and as you can see here, when acceptor accepts a connection, it just sends that connection to a sink. I don't think this is what we want to do. We want to have some sort of a session, right? So we want to have some sort of a session in here, and what we're going to be doing essentially is just spawning the new session. So this is going to be pastebin. By the way, I remember that Erlang had question mark module, sort of like a macro thing. Yeah. So which tells you the name of the current module, but it's kind of difficult to find. Yeah, so what is question mark module? So because as you can see, I'm constantly referring to pastebin module in here, but what if I change the module name in the future? what if I change it in the future? So it's going to be kind of difficult to change it like everywhere. So is one predefined macros, and it expands into the name of the current module as atom. Right, so I think it would be better to actually use this kind of thing. So module like this. So now if I'm going to change the name of the module, I will have to change it in a single place, which is kind of convenient. Right, so in here we don't send this thing. All right, so we create session like so. And maybe that session should accept a socket, right? So here is the socket that we accept. So that's this session. So in a session, again, is going to transition through several states, right? So we can actually expect a state as an argument in here, right? So you can pattern match on the arguments of the functions, and in here we can say, okay, so sort of like an intro. Like waiting command, or yeah, so basically waiting command. And when we waiting command, we specifically waiting for either post or get. Right, so this is what we're doing. As soon as we get one of those, or we switch into the corresponding states. All right, so command, if we are in a command and we're starting from the command mode. Right, so we're starting from the command mode. So in here, we're probably going to be receiving the message, right? So that's the function used for receiving the message, like so. You can actually receive you can just do receive. And if I remember correctly, if you set the length to 0, so argument length is only meaningful when the socket is in row mode and denotes the number of bytes in a row. If length is 0, all available bytes are returned. So we're going to be accepting like by packets. So essentially in here, we're going to say, okay, expect 0 in here, expect 0. And the thing we can do in here, I think it makes sense to actually match what we receive. So the result is either OK or an error, right? So if it is an OK, so we get the packet. And this is where we have to parse, right? So parse packet. So I'm going to put it like that. If we receive an error, or maybe we can say if we receive something else, right? If we receive something else, I suppose it makes sense to instantly close the connection, right? So you just close that specific connection. And you return out of that. You just return out of that. So yeah, maybe silently. I think there is no need to even say anything, right? So if there's an error, just like don't do that. Maybe logging something would be nice, right? So maybe logging something would be nice, and let's go ahead and do that. So this is going to be error, and here is the reason. IO format. So we can say session, like error, session failed, and let's put something like this in here, and let's put a reason in here. So we're going to be logging that to std out. So as we parse in the packet, all right, so one of the things we can do in here, maybe we can pattern match this entire thing. So as far as I know, in receive, we receive binary stuff, right? So and the binaries are actually wrapped around in these like sort of brackets, right? So there's a difference between strings, right? There's a difference between strings and between the binaries, right? String is sort of like a list of Unicode code points, right? Generally, I think, and bytes are just like basically bytes. It's binary stuff. So and in here, maybe we can even, explicitly just look for something like post. So as far as I know, telnet sends you out new line when you press enter, but I don't remember, does it actually send out /r/n or just /n? So what exactly does it send out? I'm not quite sure. One of the things we can do, we can actually have a packet, right? So we can do a packet, and we can just print this entire packet on the stand output, received. So something like that, and this is going to be packet, and then we're going to close the connection for now and just return OK, right? So for testing purposes, right? For testing purposes. Okay, So because of that, by the way, we don't really need a server anymore, right? So because we're building a completely different thing. So acceptor now creates sessions that work with particular session. Because of that, we only need the acceptor, right? So that's the acceptor thing in here, right? So we just return acceptor. Because of that, it doesn't really make any sense to do anything like that in here. Okay, let's try to compile this entire thing. And so acceptor doesn't need a sync anymore. Async. So yeah, I forgot a dot in here like that. So acceptor has one. So because of this language is so dynamic, I'm a little bit afraid to fuck something up. Right, so acceptor now accepts only lsock. So this is lsock, and a session is not used. So let's put session maybe in here. Okay, finally all of that compiles. So now if I start this entire thing, no matching function to start. Fascinating. All right, so can I now try to do, okay, so it seems to be working. So telnet localhost 6969. And IO format, yeah, I fucked up yet again. So because I forget, yeah, so this is the most annoying thing about Erlang, is that I keep forgetting that this has to be a list. Like I keep forgetting that. This is the most annoying part. But anyway, so let me try to do that one more time. All right. So let's bring this stuff in here and. So session failed e-inval. That's very interesting. So you couldn't receive anything. Like I didn't expect that. So it literally failed in here. And this is literally what I wouldn't expect, right? So what the fuck? Excuse me. Okay. So e-inval. All right. Okay. So is it the same as receive? Oh wait, is that because a socket invalid? I see. So that's probably the reason. But it's supposed to be valid, right? So because I get the socket from the accept and I send it to here, and I don't close it, by the way. I just keep it as it is, and yeah, I'm just trying to receive. So it's kind of weird. Like that. So I'm not quite sure what the fuck is going on, excuse me. Yeah. So I didn't think I provide a socket. So does anybody notice any error? Because like that never happened to me. Like what the fuck? So just like I receive. Is it something? Okay, let's take a look at the man of receiver. Just like a C receiver. Length 0. It should be 0. We already checked it out. Support. Yes, we literally read that from documentation. I explicitly read that from documentation right before using length 0. Come on. So error. Invalid argument passed. Yeah, that's weird. That's weird. Need timeout to wait. No, it doesn't need that because it's overloaded function. It wouldn't compile if it was not possible. So there you go. Here is the socket, here's the length, and length is 0, right? So if length is 0, exactly length byte, okay. So if length is 0, all available bytes are returned. So length can be equal to 0, as you can see. Length can be equal to 0. Right. So /r/n messing. What are you guys talking about? Receive returns e invalid error no. What the fuck are you even talking about /r/n? If socket is not passive mode, the return value is error. I think. Okay, so this is finally something related to what I'm doing. So it's not a passive mode. Why does it have to be in a passive mode? So did I forget to maybe... So I was actually able to Okay, so let me take a look at my chat and how, nah, I don't want to look into how I implemented that in chat. Okay, so let me see, Erlang, again, TCP example, right. Aha, active false, yeah, this is related to what I need, thank you so much. So it's something about active, yeah, so it's something about active. So thank you chat, you're the best, some of you, not all of you. There we go, finally we're talking. Okay, so this is what we got. So yeah, this is a /r/n 1310. So because of that, I should be able to do something like post maybe /r/n, right? And in here, right, so we can also do, well, I mean, it would be kind of cool to partially match the binary. So it would be kind of cool to partially match the binary. So maybe something like get. And then an ID. Is that something we can do in here? Is that something feasible even? That's something feasible. So this one has to be obviously a variable. Anyways, so here we can say post mode, to do post mode, and then you close this entire thing. And then get mode, and you close this entire thing, and just do something like okay. All right, so let's try to compile this entire stuff. And so we don't have a packet, right? So that is not a thing, or yeah, it's probably overloaded for this specific stuff. All right, ID. Yeah, we can maybe specify the ID that we got in here. All right. Okay, it's kind of cool. So I think I can partially match this entire stuff. I think I can. So on top of that, I probably want to trim the whole thing, but it's not really needed because I'm just printing this entire thing as is. All right, so can I restart the whole stuff? Address reuse. So didn't I say explicitly reuse address? So it doesn't allow me to reuse the address for whatever reason. Yeah, I should be like killing the whole thing. All right. Okay, let's do stat. And in here, right, I can do post. Okay, so this is a post mode. We actually matched this specific thing, which is cool, I think. Right now, if I'm going to do telnet, get some sort of ID. And it didn't match. It actually didn't match. So, which is kind of weird, right? I would expect it to maybe match this thing, but this is not how it works, unfortunately. I don't remember how to do that. So Erlang pattern match binary, even though I remember we did that on the previous streams, right? We did that on the previous streams. Just for the reference, what is that? Tunnel protocol. Jesus fucking Christ. We already, not only you are completely missed on what's the problem, we already solved the fucking problem. Anyway, Jesus. So yeah, I remember, so constructing matching binaries. So this is ec/binary. Aha, this one is interesting. Okay. All right. So this is, maybe that's how we do that, /binary, but it's not really important, right? So one of the things we have to do in here is, by the way, so this is the message. We probably don't even need this kind of thing. We can just maybe say something like, right, maybe, do we want to send anything back to the user? Do we want to send anything back? Again, TCP send sock, right, invalid command, yeah, /r/n, invalid command, and it may fail, but we don't really care, I think. I think we don't care, so we're going to close and we can just exit with OK. So invalid command. So funnily enough, as we receive the post. So we successfully actually, you know, receive the post command. We can go into a session like this, session post socket, like so. So, and in here, session post socket, which, like, it's not implemented yet. And I suppose this is what we want to do in here. So you can organize like state machines like that, right? So you have a function, you receive some stuff, you go into the same session but with a different atom. So pattern matching is going to actually go to a different sort of branch of the thing in here, right? So this is like a cool part of Erlang. So let's close le socket. Let's close the socket, and this one's gonna be okay. So I didn't really want to do that. Okay, so yeah, let's try to maybe kill that and do one more time. So yeah, a literal string in the binary, we have to type a size. Yeah, bit string. I think what I have to do in here, I have to say that this is a binary. Right, yeah, so we say that we expect this to be a binary. Right, and that's how we, you know, receive something from get. In fact, do we? Yeah, I think you have to put at least one space in here. I think at least one space is required in here. All right, so the message is really not needed, so we don't care, right? So if you didn't match any of these things, like, we literally don't care. All right, so let's do pastebin, like so, and let's connect, and I want to get some ID. Look at that. We got some ID. Then I do post, and this is a post mode. Right, so we can distinguish between these things. Right, if you put something else, you get invalid command and you get a closed connection. That's pretty cool. That's pretty cool. So interesting thing about ID is that it contains /r/n, right? So 1310, it says /r/n. On top of that, if you actually do something like a bunch of spaces, some ID, a bunch of spaces, you get something like this, right? So, which is kind of annoying. I think we have to trim the whole thing, right? So we can also exam 3 in the match. It's actually a really interesting idea. I'm not 100% sure. Can I do /r/n? Because I feel like, yeah. So binary field without the size, like, it doesn't have size. Because of that, it's a trailing thing, right? You have to specify the size. If it doesn't have a size, like, it doesn't make sense, right? It doesn't make sense in here, right? So because of that, I feel we have to match it like afterwards. So the idea is going to be to use something like trim. As far as I know, IOLib, I remember using this thing, had a trim. Actually string, I think it was string. Let me see. Yeah, so you can do trim in here. So let me try to do that. So here is the ID, and I will just do string trim. So is it going to compile? Yeah, it seems to be compiling. All right, so let's do that and get some ID. And there we go. Here is some ID. Isn't that a poggers? I think that's pretty freaking poggers. So let's actually print that as a string. Let's print that as a string. Right, so I'm going to do that one more time. And so get some ID space, and we got some ID. So we got all the necessary information. That's cool. So now what we want to do in here, we want to do session get ID, actually trim the version of the ID, right? So it's a trimmed version of the ID and the socket, right? So, and I think that's basically it, right? If you get the post, you go into the post mode. If you get, you get into the get mode. And in here, so session get ID, ID sock. And what's interesting is that it's a function of a different arity. So that's the thing. It's a function of a different arity, because of that, it cannot be part of the same sort of like a pattern matching of this stuff. So you think, you know what I'm going to do? I'm going to actually pass it as a single thing in here as a tuple. Right, so something like that. Because of that, so now it's the same arity. So it's part of the same sort of like thing. Because like it get additional sort of state in here. It gets an additional state in here. So post mode, post mode get mode. Post get, so it's a string ID, and we just close this entire thing and okay. All right, so I think we are basically done with this specific state, with the state of the command, like accepting the command, right? So accepting the command. So now we have to do post. So what do we even expect in here? I suppose we expecting lines until, let's take a look at the spec. All right, we have a spec in here, until you send submit, right? A single line that is submit. So that's what we expect in here. So let's do a similar thing in here. In a session, we are receiving everything, right? So we are receiving everything, and we may actually receive some sort of an error. And we're gonna do the same thing. We're gonna just say session failed, and we're just gonna exit, right? So we're just simply gonna exit. If session didn't fail, we got okay, and specifically we expect submit, right? So we expect submit, and I don't know, so we can just say that we expecting the rest of the binary in here, but it's kind of difficult to tell. Let's say that we expect specifically submit /r/n, right? So if you have any space in here, or maybe some space in here, is going to be treated as part of the text. You have to explicitly send submit like that, right? So that's what you have to do. So, and in here, because of that, so as soon as you, you know, submit something like that, session changes its state, right? And I think it has to go into the challenge state. Challenge state socket, like this. So it goes into the challenge name. So otherwise, what we get in here, we get the line, right? We're just getting the line, and we need to accumulate the line somewhere, right? We need to accumulate the line somewhere. So the question is where we're going to be accumulating the lines. Right, I suppose we can accumulate the lines within this state in here. So as you can see, in the get state, we keep ID. So in a post in here, we can actually keep the lines, right? So here we can say, here are the lines that we submitted so far, right? So here are the lines that we submitted so far. And that means that we should not forget, when we switch to the session in here, right, to the post, to change stuff to something like this. And this is the annoying part of Erlang, is that you want to have a static typing in here, chat, right? So I modified kind of the signature in here. I should not forget to modify it in here. So a statically typed language would have literally told me that, right? But as already said, Erlang has an optional static typing thingy. Right, it's called type specs or something like that, right? I don't remember. Like, somebody from Erlang police, could you please correct me on how exactly the type specs are called? Am I calling it correctly? I hope I didn't offend any professional Erlang developers out there by calling it type specs. Right, maybe it's something else. I don't fucking know. Sorry. Don't call the Erlang police. So, right, and actually you can find a lot of examples on this kind of stuff within the distribution of Erlang itself, right? So here is the distribution of Erlang, type kex, yeah. So here's the libs, and somewhere here we have like, yeah, so here is a bunch of libs that go into the standard library. So one of the things you can find in here, I suppose, is gen TCP, but I think gen TCP is part of some other package in here. So let me find gen TCP. So it's actually find name gen TCP. So it's in a kernel, right? So let's actually go into the gen TCP because I think it's a pretty good example. So specifically, I'm interested about the receive function that we use all the time. Look at that. So let me disable the white space mode because they use tabs. They can freaking mix up tabs and spaces. And these people are correcting me about my usage of terminology. Think about it. Anyways, so here is the receive function. It has a bunch of mumbo jumbo for pattern matching, which I do not fully understand, but I don't really need to. And on top of that, they have doc, right? So you can actually have like documentation and stuff like that, and spec. So dash in here means that it's kind of sort of like a preprocess, I think, right? So it doesn't really affect anything per se. Right. And what's interesting is that, like in here, you can say that receive function with the arity of 2 with these variables returns this or this. Right. So it's kind of like as powerful as a TypeScript. You can say that a particular function may return that or that, that or that. Then, for example, here you can say that socket is actually socket. And what is a socket? It's actually a custom type, right? So as far as I know, we can try to, yeah, there we go. So it is defined somewhere. So this is a part of the documentation, but usually you can define types with this sort of macro directive dash type, right? And so socket is basically an alias to inet socket. Do we have inet? Yeah, there we go. So socket, there we go. So as you can see, socket is either port or module socket. So I don't remember what is port, maybe it's something. So the yellow indicates that it's something built in. It's something built in. So in a module, we can, yeah, so I actually found it instantly. Module is, I suppose, a tuple, the first atom of which is $inet, and then within it, it has 2 handles, which are modules. So it has a like a complex type system. Right, it has a complex type system, even though it's a dynamic language, it is like feels like as powerful as at least TypeScript. There's a lot of like type related shit in here, and none of that is checked at runtime. All of that is just purely for documentation or external tools. There is a thing in Erlang which is called dialyzer. So, and this is the external tool that uses all of these annotations to check things, right? And it comes with the distributions of Erlang, right? It's a little bit weird. I don't quite understand the, you know, UX decisions behind that tool, but it kind of works actually, believe it or not, it kind of works. So we can try to maybe call it, so dialyzer. If you try to call it, oh, command is not found. You're supposed to like, yeah, I don't have it in path in here. So here's OTP28, dialyzer, right, it's actually called. So if we try to call it, it couldn't find PLT files. So PLT is kind of a weird concept. Just a second. It's something tables. So it's some sort of a tables. This is where they store types or whatnot. So Erlang types PLT. So they have a lot of weird terminology, right, that only Erlang people understand. What PLT stands for? Erlang police. Could you please correct me about what PLT stands for? Because I do not remember. Persistent lookup table. That's what they're called. So yeah, dialyzer stores the result of analysis in a persistent lookup table, PLT. They give the definition of this thing only once throughout all of the documentations, and they never mention full name of this thing again. They always refer to it to PLT without any additional context. Like, they don't give a shit. And they have lots of things like that. They have PLT, they have beef. Do you know what is a beef? Right. So, and if you read Erlang, Penny's latest tomato, yeah, so that's what it is. So, yeah, built in, but I mean, nobody fucking calls it like that. Nobody fucking calls it. It's only Erlang that calls built-in functions beefs. And they never gonna even explain to you what that means. Throughout the documentation, they're gonna be throwing around just, oh, okay, just use this beef and go away. Oh yeah, so you want to use this beef. Oh, we have this beef, and like they never actually like translate what the fuck it means. You have to like accidentally stumble upon it somewhere. So they also call the FFI NIF. Yeah, they have completely different set of terminology, separate from the tag. maybe that's kind of the point. Like, well, maybe that's kind of cool, right? So they sort of separated themselves like with the wall garden, right? So to keep the normies away. So LLMs, by the way, help with that. So it is not, the problem is not that they use all of this terminology, is that the problem here is that all of their terminology is extremely unconventional. It is extremely unconventional. Like nobody calls this thing like that in the like wider industry. It's only them who's doing that. Like they develop their own fucking language. So it's kind of funny, right? So it's kind of funny. It's a little bit frustrating when you first time working with this entire stuff. Because it's old, yeah. So that's understandable. It's because it's old. It's kind of similar situation like with Blender, right? So I remember 3D artists complain a lot that Blender has a lot of unconventional key bindings and ways of doing things. And the reason why it does so is because it's very old and it evolved completely separated from the rest of the industry standards, right? So it's kind of a similar situation, right? So it's a very old tool that was living in its own bubble for way too long. So, and that's basically what's happening in here, I think. Erlang is a very old language that is living in its own bubble. So, yeah. And that's why it develops all this like weird terminology and stuff like that. So Erlang is not that ancient, actually. It's 1986, newer than C++. Well, I mean, okay. So it's PLT. So this is where they store all of that stuff. And so you have to, like, they don't ship the PLTs for the standard packages of the language, right? So you have to build them yourself, right? So the first thing you have to do, you have to say, okay, build the PLTs for these libraries that come with Erlang, and it may take some time. So this is a tool that just checks types, right? So before checking types, it needs to traverse standard libraries in a very slow fashion, by the way, collect some sort of persistent tables and store them somewhere. And on top of that, it exited abnormally because it didn't find some of the functions, but this is fine, we're not going to be using these functions. Dialyzing, yeah, so anyway, after that, to use that, you can't really use it on the source code, right? So you can't really use it. Oh, you can use it on the source code. Okay, so that's like, the last time I checked, I think you had to do SRC, but I think they fixed that UX. Okay, so and it just tells you where you have some problems, right? So yeah, function session2 is undefined, right? So there's some problems in here. But I think this specific output is not particularly useful. Let me see if it does any difference. Yeah, it doesn't do any difference. Right, so I think what we need to do in here, we have to specify this spec, right? So let's do spec session, and here I accept state, right? So here is the state and a socket. And what I'm going to be returning in here, I think in any case, we're going to be always returning OK, right? So because if error happens, we just log that error, close the socket, and we return OK. So this is basically what we expect in here. So again, TCP, and then, so let me find receive. So just need to find the function receive. So yeah. Here is the spec. So then after the return, you do when, and then you list what each individual type mean in here, right? So then here I can say when state, and now I have a perfect opportunity to even like have a list of all of the possible states. So state could be command, or what else could it be? It could be post, and then lines, right? Lines is a list of strings. I think that's how we do that, right? So state is a like list of strings, or maybe it's going to be list of binary. I think it's a binaries, or like I remember there was like a type for binary. So if it doesn't exist, it's going to complain about it. Then or get, which is a binary, yeah, so the binary here is highlighted with yellow, but here it's, I think it's something with Emacs. And that's about it, right? So essentially you can like document what kind of states we expect in here. So then socket is a socket from GEN TCP. It's a GEN TCP socket, like this. I think that's it. So if you go into GEN TCP, there is a type socket in here, which basically forwards to iNet socket, right? So you can explicitly say that we expect socket from that specific module in here, right? So here is the spec. Now, if I try to do dialyzer, I think it will tell me more. Yeah, so there was 2 errors before, now it is 3. So here's the session, unknown function session 2. Yeah, so that's kind of interesting. Function session 2, is there like, is undefined. Spec for undefined function, that's kind of weird, right? So here's the session function, and I use it all the time, and it tells me that it doesn't, because there is syntactical error apparently in here. So let's try to compile the syntactic. Okay, so that seems to be compiling. So now it should be working. Yeah, there we go. So now it is telling me shit, right? It is telling me shit. So the call to this function, it instantly caught that. This is exactly what I was originally talking about. So because state is expected to be command or pair that has a post or pair that has get, but never post or get, right? So on its own. And here this is a type mistake. And dialyzer instantly caught that. So now what I have to do in here, I just have to put an empty list in here, and I think that error will go away. Right, so there's now a different error. So it's called to the get, but this is a string. So this thing is expected to be binary, but I feel like trim in here returns a string. So let's actually see what it returns. It returns a Unicode char data. Okay, so can I just, yeah, we can explicitly say that maybe it's a Unicode char data. Okay, at least for now, but I would like to keep it, I'd like to keep it as, yeah, as that. So, and now that's a good one, right? So I introduced a new state challenge that I never actually documented in here, right? I never documented in here, and now I have to edit in here. So you can actually use Erlang as a statically typed language. Erlang has static types with dialyzer. It's a little bit weird, but you can do that. It's kind of convenient. I kind of like that, right? Because I think like every time I programmed in Erlang, this is exactly what I missed, and I only recently discovered that. So char data is a list of chars as far as I know. Okay, so let's actually see. So there should be a Unicode function, a Unicode file somewhere here. So type file, name Unicode. So URL. So here it is. So char, what was the char data? Okay, type char data. And it's a char list or Unicode binary. And Unicode binary is just binary. Yeah, this one is, how can I force it to be binary? So this is pretty strong. Yeah, it is pretty strong, right? So like, it's actually kind of pleasant, especially if you're coming from languages like Husky or something like that. When you discover how to use dialyzer, it is actually kind of fucking cool. So yeah, so here's the challenge. And so let's try to compile it one more time. So what do we have in here? Yeah, so I suppose this is because we never really matched that thing. So let's have challenge. There's going to be a sock. And for now, I'm going to just say like, okay, right? So it's not implemented yet. And now if I try to do that, there we go. It passes all of the stuff. So you can have static types, which is rather convenient. So don't forget to build the PLTs first, right? And then you'll be able to use dialyzer. There might be some to binary function. Yeah. So what I'm thinking is that, okay, Erlang string to binary. Let's actually see. Convert a string to binary. just to enforce it. Though, like I want to be able to trim. Is there something like a B trim? So Erlang B trim, because yeah. So B trim. So yeah, that's a bit annoying. Anyways, so Erlang converting string to binary, list to binary. Okay. And I suppose if I take a look at the Erlang list to binary, it returns a binary. So it's kind of weird that, yeah, that it takes a binary, it trims it and gives you list instead of actual binary, and now we have to convert it back. So I do not mind that. I just find it a bit weird. I feel like there could be some problems in here. So here's the list binary, and I'm sure it is going to be fine. But it is sus nonetheless. So called pastebin, so exactly does it return. Port will never return since it's different the first argument. Get list any. Oh, yikes. Anyway, so let's not focus on it too much, right? So because I think I'm wasting time on this, right? So let's just say this can be Unicode data. Whatever, because it's kind of easy to fix later. Okay, so we have a post, and when we are doing the post, we go into the challenge. So here it is. When you get the line, I'm surprised why Dialyzer didn't complain about this part, but it's fine. So we do session, right? So we do session, and we sort of accumulating the lines in here, like so. Right? Every time somebody submits a line, we just accumulate all of these lines. And then when it's time to do the challenge, I suppose one thing we also have to do is that we have to pass all of the lines we accumulated into the challenge state, which means that here we're going to have the lines. All right, which also means that challenge is a list of binaries. Binary like that. Emacs, don't be silly, Emacs. Okay, so that's kind of cool. And when we do the challenge, I'm gonna close the socket and I'm gonna do format to do challenge. Can you just autocomplete the word challenge, you silly? Emacs is being dumb. All right, so, and let's put lines in here. There we go. That's pretty cool. So let's actually check the dialyzer. And what do we have in here? Okay, so that everything seems to be fine. Now, can I start le server? And it couldn't start, right? So let's do that one more time. All right, so that's cool. And then I go to telnet. Okay, I want to do post. And I do hello world foo bar submit. There we go. Yeah, that was interesting. So it just crashed, but I'm not really sure why exactly it crashed. I think I know why exactly it crashed. So challenge, because I forgot the new line here. But I mean, it kind of did the right thing. Right, so let's actually do something like that. Let's restart the whole thing. Right, so sub post. Right, so foo bar buzz sub. Don't fuck it up, please. Okay, so in here we got into the state of the challenge, and we also get all of the lines that we received from the user. Right. So that's pretty cool. So as you can see, we are like advancing all of that stuff. And we can actually maintain several connections, right? So who said we can't maintain several connections? telnet localhost 6969, right? So here I'm going into the post mode, right? So this is the post mode, but here I'm still waiting for in the command mode, right? So I can do get ID, and something got fucked up. So that's really interesting. So why? Well, at least I'm glad that we caught an error in here. Right, I'm glad that we caught an error in here. So if I do submit like that, so it's closed, but something with the get really fucked up. Like, I'm not really sure why. Like, what do I have to put submit? No. Yeah, that's bizarre. So the get state got broken for whatever freaking reason. So I was actually trying to figure it out. So this part got broken. Like, I expect if you do get, so if you do get print is not, yeah, so it crashed as well. All right, so it crashed as well. Cool. Thank you so much. And yeah, so that's the annoying part. And what's funny is that this shit with maybe not needed pattern matching or no, it's not that. Well, what's annoying about IO format is that even dialyzer doesn't catch the list, right? So if you put not list in here, dialyzer doesn't catch that somehow, right? It's probably works like that. Like, I don't fucking know why it doesn't catch that. Maybe it doesn't have a spec, but I think it does have spec. But anyway, okay. So yeah, if I do get ID, okay, it crashes, it just closes that. So, and yeah, let's actually test that one more time. So it's a post full bar, and here I can do get ID. It crashes that, but it continue getting stuff in here, and then I can do submit. So as you can see, it does this independently because all of that operates in separate threads or in separate processes, whatever, doesn't matter. So it's kind of cool, right? So each individual session is like a separate session, literally separate session. And like you switch between the state. It's kind of convenient, well, for state machines, right? So it's super convenient, really like that. Okay, so specifically for the challenge, we need to probably generate a random string. We need to generate a random string. So because you are supposed to concatenate that random string with your text and do the challenge, right? So it's going to be SHA-256. So we actually need to estimate how much time it takes to, yeah, to just actually do proof of work, right? Maybe we could do that maybe in Python, right? Somehow that would be interesting. That would be interesting to do that in Python. So okay, I don't know how to do random numbers in Erlang. So let's actually see what's the function. It's called rand. Okay, so let's go into OTP. So I'm pretty sure there's a directory with the name rand. No, it's not there. Is that third part? Oh, it's in stdlib. Okay, all right, let's go there. So do you have rand? Oh, there we go. Here's the rand. Okay. So that's pretty cool. Can I just generate a random string? Provide pseudo random number generator and implements a number based generator algorithm most provided through plugin framework. It's a their random number generator has a plugin framework. Jesus, broski. Well, I mean, it kind of makes sense. Maybe the random number generators in Erlang, since they're working with telecom stuff, they have to be cryptographically secure and stuff like that. So it's kind of a complex thing. It's kind of a complex thing. So do they say PIF? Did they say PIF anywhere? Oh yeah. Oh, plugin framework. Plugin framework. Yeah. So PIF, obviously, fucking PIF. Okay. So rand uniform. So it's called rand uniform. Sure. Pastebin rand uniform. Okay. Oh, it's just like a float. Okay. What if I do a function? Okay. So it always returns float. All right. So random uniform. So you can do seed and stuff. I'm curious. Is there something like a string? can you return a random string or maybe a random binary? Don't quite see it. Don't quite see it. So there's different ranges, types, dummy state, dummy thick, dummy thick. Yep. Okay, so let's actually ask the LLM. Okay. Generate random string in Erlang. Don't yep. Okay. Module random string. Are you fucking serious? Oh, fuck you. So there is a crypto. Okay, so human is better than AI confirmed. This is bullshit. Like, holy fuck you. It literally fucking suggests to use random uniform that returns floats. Motherfucker suggests to generate floats. Holy fuck. Like, how people even say that those things are good at programming? They're trash. Straight up trash. The only way you can see it being good at programming is if you are bad at programming. Like, it's just like, it's fucking trash. Anyway, so crypto, this is an interesting one, right? So, anyway, it's how many years it's been, right? So since 2002, 3 years, right? So we're gonna achieve singularity. In how many years we're gonna achieve singularity? In 5 years, so we have 2 years to go or something. Like, so singularity, when exactly is the date of singularity? I'm not quite sure. Anyway. So crypto, so find directory name crypto. Okay, so here's the crypto. So, and people say that it's like a random string, or was it so strong rand? Thank you so much. Nauk. Okay, so this is kind of cool. Like, it literally has what I want. This is so cool. Strong rand bytes. I wonder, so let's actually find that. So, and there is a documentation. Generate bytes with a random uniform value. Oh my god, thank you so much. Returns the result in a binary with n bytes. So how, like for real, what was the prompt? Yeah, I explicitly say generate a random string in Erlang. I'm pretty sure all of that shit was in the training data of that LLM. So the GPT-04 or something. Just didn't prompt it right. Just didn't prompt it right. Skill issue. Uses a cryptographically secure PRNG needed and periodically mixed with operating system provided entropy. Holy shit. So ask it XD. Okay. It generates random bytes. Ah! It thinks that it has to be specifically printable. I don't even know how, like... I don't know what to say, honestly. Who are all of these people who tell, like, I just one shot at 1 billion startup? Who are all of these people? Are these people, like, literally bots? Or is just, like... Who are all of these fucking people? I don't understand. It's fucking psyop. Literal psyop. Anyways. They're bots, probably. They're probably bots, all of them. Or, again, they probably don't know what the fuck they're talking about. So, which is more likely, honestly. Which is more likely. Just a new .com bubble. Yeah, this one it just can't really burst yet. right? So it's kind of like this bubble this time is more sustainable. It is more sustainable. Burning a kilo of coal in energy to show anime titties. The problem is not the energy. This is a fucking wrong argument to use against those people. Nobody gives a shit. Using energy is good. Energy is good. There's a lot of energy in the fucking universe. We have an entire fucking like a hydrogen fusion reactor in the center of fucking solar system. Like, there's a lot of fucking energy. We should fucking use all of that. The problem here is that all of that energy is is used for trash, right? All of that is trash. Like, all of that is a fucking trash. That's the problem. Not that we use a lot of energy, but because it's all trash. So, yeah. I don't know how people trust anything. Well, I don't know. I don't know either. I don't know either. It's just like all of the stuff with LLMs like revealed a really weird thing is that you can convert like you can convince an average normie in literally anything if you just say things in a very specific, confident way. It's rather bizarre, actually. Like, I didn't know that. Like, and what's interesting is that it actually kind of explains how cults and religions get born, right? So because it's kind of weird, like how cults and religions get born. It's just like apparently like very charismatic people were just saying things confidently enough, and that's enough to convince a normie. That's the scariest thing. That's the scariest. Like you just like you don't need to have a logical consistency or anything. Like it's just like you just have to say things confidently enough. That's it. That is enough. You can convince in anything, even in the contradictory things. It's like it doesn't matter. It is fucking scary, honestly, like to actually have a proof of that in forms of LLMs. Yeah, so politics work like that all the time. It's fucking scary, man. It's fucking scary. Yeah, but anyway. So yes. Users OpenSSL. By default, this is the rand bytes method from OpenSSL. Okay. Strong rand bytes. So strong rand bytes is a non-integer. So you know what I want to do? I want to actually take a look at the man function here. Man function. Crypto, like that. So strong, finding function. Okay, so you couldn't, Oh, wait a freaking second. What is going on? Am I being stupid? I feel like I'm being stupid, chat. What the fuck is going on? Why does it accept bytes? So generating bytes. Use the cryptography PNG. So what is this? Is this a seed? I don't quite get it. Is this a seed? I don't understand. What is that? Because it's supposed to return binary. Right, I suppose it's a seed. So we're gonna maybe use that. Bytes is the length. I get it. Okay, so it's kind of, yeah, so it's named bytes. Like it's called N in a spec, but here it is called bytes. Why don't you just call it N? Freaking looking at that. Yeah. So it's called N. It's bizarre. So maybe they forgot to change it. So that's understandable. Crypto, like generate me 69 of those things, please. Let's go. Okay, that's pretty cool. So, and I have to kind of convert that to hex, I think. Right, so I have to convert that to hex. So Erlang binary to hex string. Let's fucking see. IO formatting to binary to hex. Okay, so I think I saw something, chat. Integer to list. All right, but it's a Okay, so there is an integer to list, and I can provide 69 and 16. All right, but if I provide like a binary 69, 69, is it go? Nah, you can't do that. So it has to be specifically that. All right. So there is some function that lets me convert. Yeah, okay, so people suggest to implement it yourself, which is dumb, I believe. I think it is straight up dumb. Okay, bin ASCII, so we prefer binary crypto hash. Ooh, crypto hash has some stuff. So let me see, crypto hash SHA, and I can just put some stuff, right? And it's not, yeah, it's not that. So binary, okay, so binary encode hex, thank you so much. Binary encode hex. So, and it's 69, 69. Yeah, finally. Cool, thank you so much. So that means in here, I can finally do crypto. So was that strong random bytes, 32. Yeah. So this is gonna be like basically your challenge. Like I think 32 bytes here is enough. Okay, finally. I got that. We freaking got that. So challenge and yeah. So what is it? Gen TCP send main function. Let's go. So it accepts socket and packet. So sock. Let's put that stuff in here. I suppose I probably want to assign challenge to a variable, right? And I want to send that to the user. So IO lib. I remember there was a B format which allowed me to do this kind of thing. So this is the challenge, right? This is the challenge, and so this is the string, but I'm not sure if it's a correct thing to do, but whatever. Right, and we just send in the challenge. Though, yeah, I don't need a format. I forgot. Shit, I forgot. I can do shit like that. I can actually do shit like that. Where challenge, yeah. So I'm just sending this entire stuff. So after sending, I have to switch the state actually. I have to switch the state and go into maybe accept. Session accepted. So I expect certain lines and certain challenge. So here is the certain challenge. And I'm waiting for, essentially waiting for the suffix, right? So accepted suffix in here. So this is going to be sock. And that's about it. So here's the challenge. Here's this stuff. Can I? Oh yeah, I can actually do stuff like that. So now we have accepted, and in the accepted we have the lines, right? So a bunch of binaries and a binary, the challenge itself. So that's basically what we're expecting here. So accepted lines challenge is going to be sock. Okay, so and in here we just wait for a certain challenge. We can actually wait a certain amount of time, right? So essentially, if you timed out, right, you failed the challenge, right? So we're gonna completely forget this entire stuff. I'm gonna be completely forgetting this entire stuff. By the way, I think it makes sense to maybe actually keep this thing above, right? Because here is everything related to post, right? So after command, we go into either post or get. So here is the post, post goes into challenge, challenge goes into accepted, right? And then get goes here, right? So sort of like branching out, different states branching out in here. Right, so IO formats. We can actually send something interesting in here. So we can send, all right, challenge. Yeah, we have to wait, right? So let's do something like this. Receive. So here is receive off. And if it is okay, we expect accepted, right? So we expect accepted and then the ID that is a binary. That's what we expect in here. So this is going to be to do, not implemented yet. Yeah, that's bizarre. What is going on? Why? Oh yeah, everything's fine. So either it's okay, but it is something else, right? So this is another situation in here. We received something, but it is something else. So we have to probably say something like an invalid command as well. Right. This is invalid command. And we close this entire stuff and just exit with OK. Then we can have an error with the reason, and we can just copy paste this entire reason like this. In fact, I think we can factor out this entire stuff into some sort of a function like a fail session like this. Just fail session. We're gonna accept the reason, maybe socket and the reason. I think that's a good way to do that. So error in here is just like a fail session, socket and a reason, and we don't have to think about it too much. Fail session, socket and reason. Fail session, socket and reason. Why can't I type reason like so? Okay, the compiler doesn't fucking compile. Why? Why don't you compile? Oh, that's because it's a dot. Yep. Anything else? So this is unused. So all of that is just like unused variables, which is fine. Let's try dialyzer now. Let's try dialyzer. Okay. So it fails. Aha, this is because challenge accepts more. Well, I mean, it accepts lines. What the fuck are you talking about? Bro, what the fuck? So we'll return binary construction, so it doesn't like something about this kind of stuff. Since the value field change has a type. So men has type 16, but it's not a. That is kind of weird. Encode X. Wait. Why didn't you find this function? In man, there's no function. Bro, it couldn't find it. Did chat lie to me? Well, I mean, we actually tested that it works. Encode X. Something weird. Alright, so encode X, yeah. So what does it return? Yeah, it returns a weird type. Like, bro, why do you return this weird type? But it's a freaking binary. You should be able to compose that. Dialyzer is being dumb, in my opinion. I think Dialyzer is just straight up dumbass. I think session fail. That's an interesting idea, honestly. That's an interesting idea. Just a second. Yeah, but it's already too late. Dialyzer suffer from that sometimes, yeah. So, but I mean, it's helpful sometimes. It's helpful sometimes. Okay, so let's try to maybe run the service. This is not what I want, but I want you to do paste beam start. Let's start the scheiße and telnet localhost. Okay, so I want to post shit. Full bar buzz submit. Boom. Fuck. All right, so line 44 it says. Well, I mean, it actually failed exactly where Dialyzer said. So that means you can't construct shit like that. Okay, so let me see. bad argument cause to integer type. Yeah, so you can't do shit like that. That's bizarre. Which is kind of weird because this is binary, isn't it? So I should be able to compose binaries like that. You know, I feel like maybe I can actually send all of that stuff as a list, right? So that compiles, right? Because I remember like send probably accepts this kind of stuff. So let's take a look at the dialyzer. Unknown function. Okay, so now it complains about unknown function, right? So we could just do something like add apps. We just didn't build PLTs for crypto. Let's build PLTs for crypto. Maybe it will take some time. So it has some unknown functions, but I mean, yeah. So this is a little bit annoying because that rebuilds it from scratch, which removes previous. Like, here's the thing. I do not understand why, as a user of Dialyzer, I have to build some tables. I never have to build tables of any types in any of the compilers or in any of the linters or analyzers like TypeScript, MyPy, or anything like that. I, as a user, never had to do that. Why it is required in Erlang? Like, there's zero UX justification for this, for doing this shit. Like, what is UX like? What? Why? Why you making your users suffer? Is that because you Erlang and you don't have any users? Got him! I'm sorry, I'm joking. Yeah, so it's still kind of weird, right? So so maybe because like nobody uses that language, so that's why. Yeah, I see. So that explains it. So let's actually do crypto. All right, so one person in the chat was offended. Yeah, I suppose. One Erlang user. So there's two Erlang users, one in the chat and another one in here currently. Why have a low FPS? So what the fuck is the... Do you see the power grid flickering? Do you guys see the power grid in the background flickering? Chat, look. I'm using my force to disrupt the space-time. Do you see that? So it starts sending waves and shit. So let's actually see. Just a second. So it's a 50. Yeah. So it's 60. If I change it to 60, yeah, it's kind of weird. Should be fine. It's not flickering anymore. Okay. That was weird. That was weird, my friend. Okay, so let's try to dialyze this big. Okay, everything's passing. That's cool. So does it... It's not flickering anymore. Fix it. Fucking fixed it. 50 hertz, not 60 hertz. 60 hertz? Who are you? A capitalist? This is a capitalistic frequency. 60 hertz. The fuck am I even saying? Anyways, so let's close this stuff. Let's fucking go. Oh fuck! Connection refused. I didn't even start anything. All right, let's fucking go. Post. Submit. Oh, get a challenge. It already works as I want it at the beginning of the stream. That's kind of cool, right? So and it's supposed to you're supposed to take all of that shit, right? Like that, put a new line, and try different prefixes until you get like a SHA-256 that has a certain amount of leading spaces and stuff like that. So we can save this entire shit, right? So challenge txt. Right. So let's reduce this stuff, and I can do SHA-256. Obviously, you can't do that manually, right? And it's going to be like a time limitation. You have to do that through a script, and we also have to develop some sort of a script for you. Right. So that doesn't work. So we can change that. Yeah. So, and you just have to find something that has like maybe 5 zeros at the beginning or whatever, right? Like 5 zeros at the beginning. So this is basically the idea in here. And we also have to decide, do you have to use like Windows new lines or Unix new lines? Since it's a telnet and you kind of expect it to do that through telnet and stuff like that, I think /r/n is reasonable, right? So you expect it to take all of your lines of your text separated by /r/n plus the challenge /r/n, then suffix /r/n, right? So you expect it to do that. And yeah, so that should amount to SHA-256, which you know, has a certain amount of leading zeros, maybe 5 of them, or I don't know, like how difficult it is to find 5 leading zeros. Is it too difficult? Like we need to estimate that. We need to write like a Python script to do that. I'm already streaming for 3 hours. Holy fucking shit! That's a very long session. I didn't expect that. But anyway, so let's continue. There's no reason to not continue today. So today is a session for the nerds, right? Not for the normies. And I kind of like that. Kind of like today's session. 5 is almost impossible. Okay. So I never actually implemented proof of work, so I don't really have an intuition on like how difficult or easy it is to do like this kind of stuff. In fact, let's actually do some, you know, Python. So because I feel like, so the backend is going to be in Erlang, and we're also going to provide like a reference implementation of a Python script that allows you to submit these pastebins and then get them. Right, that's going to be the idea. So Python 256, SHA-256. Does it have anything in the standard library? So, right, how are we going to go that? So pastebin. It's called pastebin. So what's the... Since the server is pastebin, I think the client in Python has to be paste PYC, if you know, because it's a bytecode of Python or whatever. Okay, hashlib. There is a hashlib. All right, so import hashlib. So can you just do help hashlib Python 3 paste. Yeah, what do we have? SHA-256, okay. SHA-256. So help on a built-in function help. Oh, okay, so it's a build return SHA-256 on option initialized with a string. Okay, and it accepts like a byte in here. All right, so that's pretty cool. Okay, and yeah, all right, and it gives you it gives you objects. Damn. All right, so how do you use this object? You have to do digest. All right. Okay, so and. All right, so we got some stuff, but it's not human readable, isn't it? So there's a hex digits. Okay. Oh, there we go. That's pretty cool. That's pretty cool. I really actually like this workflow with Python, where you just do dirs, right, to sort of like get the idea what the thing is printing. Like, okay. So in this specific case, like I don't know what kind of shit I have in here. Right, so digest size, right? So there is a digest size, and then I can do help, right? And I can just explore that. So it's kind of convenient. So the Python, in a sense, like really well thought out from the point of view of different like ways of using it, and from the simplest ways of using it. So the cool thing about Python is that it's self-explorable, right? You have a Python session, and you can just explore surrounding of the session in a very convenient way. It's kind of cool. So I tuned in at a good moment, yeah. So yeah, even though it's a sloppy language, it's a pretty good sloppy language. What can I say? It's a pretty good sloppy language. I'm kind of like keep like holding keyboard in a really weird way. The digit, I just yeah. Okay, we need to read the file. So who remembers how to read the file? I think you just first have to open the file. So challenge. Yeah, let's keep it like that. So open. So challenge txt. So I remember that you can open. So with open as f, where you can just like read everything, but I do not quite remember. Can I read the entirety of the thing? Can I read the entirety of the thing? So what do we have? So there was a read lines, I think. So read lines. What do we have? Return list of lines. What if I can you just read? So read at most size. If the size is negative, omit it, read until end of file. Okay, so if now I do something like that. Okay, cool. So we read the whole thing, essentially. Can I just content and print that content? Yeah, I can. Cool. Now, what we can do, we wanna maybe generate some stuff. So here is like a optional prefix, and I'm gonna put /n in here, and that's here it is. That's how it's gonna go. So what if one of the things we can do in here, we can just use like a counter. Right, we're gonna start with a counter. I think this is the easiest way to just try to do that. While true, right, we're gonna append counter with a new line. All right, so that's the thing we're doing here. And then I have to kind of encode that. I don't remember how to go into the binary though. So if I have I think it's bytes. Bytes. String arguments without encoding. Yeah, I don't remember. So Python string to bytes. Encode. That's busy. All right. So, so str encode. Yeah. Okay. So that's fine. So we got that. So let's code s. Str encode s. This is the hash. Well, I mean it's h. And yeah, let's actually print the following thing. So it's going to be f. So suffix, which is essentially counter, hash, which is essentially that. And we keep incrementing the counter, right? So counter plus 1. Let's do like first 10 or something, just to see what it's gonna look like. Well, yeah, hex digest. Yeah, there we go. So we can do something like first 100 of them, just to see. Okay, cool. Some of them already start with 0. Right? Some of them already start with 0. So we're already doing proof of work, right? I looked away for a bit, and this is some weird looking Erlang. Yeah, I know. We're like, I'm developing sort of like a client code that is performing the challenge, right? So we're just doing the suffix. So by the way, like who does blockchains and crypto and stuff like that in the chat? How do you usually go about proof of work? Do you just use a counter, or do you randomly generate strings of different lengths and stuff like that? What's the good approach in here? So maybe you can use a counter that enumerates random strings as well. So maybe you count up to like 9 and then A, B, C, D, so on and so forth, like maybe, I don't know. Yeah, so purely on numbers, how far can you go purely on numbers? I feel like you might not go that far. We're now mining pastebin tokens in Python. Yeah. For blockchain, you are better off randomly generating strings, more probability of finding it first. Okay, that makes sense. That makes sense. Again, I never worked in that area, so it's just like I don't know what's the good approach, what's the good strat in here. And since I programmed in Rust relatively recently a lot, so that means right now in my audience there is a lot of Rust programmers, so that means there's a lot of people who know how blockchains work. Got you. I know what it's all about. Anyways, just a second, I need to pour some water. Got you. It's kind of interesting how Rust has such a huge presence in blockchain. It's kind of weird, honestly. So Rust focus on safety and being used by hackers and crypto guys is kind of ironic. I guess. I remember I think there was somebody complained that Rust enabled hackers to create unhackable malware. Right? In the sense that usually the way you counter like viruses that spread very quickly, you just take their binaries and you find vulnerabilities within the virus and you exploit those vulnerabilities to sort of shut it off. Right? So that's one way to counter that. And people said that because the hackers started to use Rust for malware, they became unhackable. Right, or something. So it's kind of this is what I heard. I don't know how much of that is true. Right, because you can still have vulnerabilities that are logical errors within the code. But anyway. I heard. Yeah, I heard. Like I just saw a random video on YouTube. YouTube just recommended me something about that. I have watched that, didn't really pay too much attention about it, and I just continue spreading potential misinformation. Welcome to the internet. So that's how it works. Anyways, so yeah. How can we? Yeah. So now we need to start counting this hash, right? So we need to see how many like leading zeros it has, right? So we have something like I, while no semicolon though. So it's kind of interesting, like you can put semicolons in Rust, but you can't put like a second semicolon, unfortunately. It's an invalid syntax. I like to annoy people who tell me that you put a semicolon. I think the way to annoy these people is to actually do something like that. Yeah. So it's a valid Python code. So it works. It gets the job done. Or you don't like the syntax, like that's your problem now. That's anyway. So while I is less than length of hex digest, right? So and we have like a count. Well, I mean we can only have I. Yeah, plus I and hi is equal to 0. And if I have a byte string, oh, by the way, the server is still waiting. Yeah. Python b. And if I take, oh, it's just a number. Can I say that it's equal to b0? I can't say that. But I mean, I can just say 40. All right. So, and in here, so we can do, yeah, let's call it count. Count equal to C. How many of them? I remember one was starting for, well, yeah. So why it didn't catch that? Look at that. What the fuck is this shit? Did I made a mistake, bruvskis. I made a mistake. How come did I make a mistake? Do you see the mistake? Hex digit. Oh fuck. So it's not. Yeah. So if I I'll explain. Okay. Man, dynamic languages. Am I right? Fucking dynamic languages. All right. So okay. So we have like ones and stuff like that. So we can do something like this. If C is greater than 0, only then print that. So we're gonna, yeah, so that's basically the probability. We can try to maybe increase that to 500 of those things. Oh yeah, there's some 2's in here. There's some 2's. So let's do something like greater than 1. All right, so that's less likely. What about 1000? Okay, so 2000, not enough. 3. Okay, there's 1 3. There's 1 3 in here, so that's kind of cool. So let's keep increasing this thing. So this is what, yeah, so here's 1 3. So what about 5,000 of this iteration? Still 1 3, look at that. So 10,000. Okay, so so there's 1 4 in here. Like I can actually 2 of them, actually 2. So let's keep increasing this entire thing. Yeah. So, and some people said that finding 5 is impossible. I kind of vaguely remember somebody said that. We kind of getting closer to find it. Well, okay, maybe you are right. Maybe you are right. What about? So yeah, so this is 500,000 iterations. So we're getting to 1 million, I suppose. By the way, can I put this kind of stuff in Python? Is that a thing? Oh, I can. That's actually kind of cool. All right, 1 million iterations, didn't find anything, but we're doing a very stupid thing, honestly. We're using counters. Yeah, so we probably should start like using random strings as well. So, so 5 millions, yeah. Oh, I think I saw one. Okay, so that's cool. So 5 millions, right, so this is going to be 4. So how much time? Okay, so here's 5. 5 is relatively easy to find, look at that. So that's the suffix. Right, so this is 5. And honestly, this is too fast. I think this is too fast. Like, look how quickly we find all of that shit. And by the way, we can actually break on finding the counter. So how quickly does it find all of that? And it's in Python, by the way. This is Python, right? It's a very slow language. And we're looping in Python, which is a huge sin in Python. So 3 seconds. Imagine what people with PyPy can do. Well, we can try to do. Do we have PyPy? PyPy 3. Oh, I don't have a PyPy. Okay, so Python 3. Okay, so all right. So what if I, what if I increase it? Okay, so let's actually say that we expect 6. Is it possible to find 6? How difficult it is to find 6? Didn't find anything. Spent 4 seconds, didn't find anything. All right, so let's do 10 millions. I'm sure Python is fairly optimized for basic stuff like sure. Didn't find anything. Okay. So loops in Python are usually extremely slow. Yeah, exactly. Those are not bytes. Those are sure, whatever. 20 seconds. Okay. I think this is definitely not the strategy that somebody's going to be using, right? So that's definitely not the strategy. Probably going to be generating random strings as somebody suggested. So let's go ahead and try to do that then. So what we're up to, we're just doing proof of work. That's what we're doing. So we have a document and we're trying to do a proof of work on that document. And we managed to do that, right? So the document is this, right? And we need to append to the document a suffix that makes the hash SHA-256 of this document have a certain amount of leading zeros, right? And we're just like trying to come up with the reasonable size of a challenge, right? So just like estimating this kind of stuff. Now let's see if Erlang is faster. I don't want to be retyping that to Erlang. Okay, so here is my quota. Here is my quota. Okay, so how do I generate a random string? That's a good question. I know there is a input random, right? So let's take a look at the random thing. Okay. Do you have a string or? Yeah, so there was a rand int, and you can sample things, you can seed things, secrets token URL safe. I don't know what that means. I'm not a Python developer. You're probably making some sort of a funny joke, funny reference in here. I have no idea what you're referencing to. Okay, look at that. Rand bytes. Rand bytes. Bro. Like, this is the reason why Python won. Seriously. This is the reason why Python won. It's just like, you want something, it always has a function. Just do that thing everybody wants to do. And it just does the thing that everybody wants to do. It, like, honestly, Python is so fucking useful. Everybody is willing to ignore how crappy of an implementation CPython is. That's kind of insane, honestly. It's kind of insane. It's just like, yeah, random bytes. Rand bytes. And you have to specify, like, yeah, there we go. There you go. But now I have to do like a hex string of this entire stuff, right? So, what's something weird with my terminal chat? Yeah. Right, so Python bytes to hex string. Bytes to hex. Oh. Okay, so all right, random bytes hex. Fuck me, bro. That's so fucking cool. And furthermore, listen, you can do shit like rand int. Is it? So I think it's like from like 3 to 10, right? And you can generate like a random length and shit. Yeah, that's kind of convenient. So we can do from random import rand int rand bytes, and it's like it's literally that. That is actually so fucking cool. All right. So this is a suffix. Didn't copy paste these Scheiße Bravskis. What the fuck? What the fuck? Boom. Here's the suffix. Then we put the suffix in here, right? So then we hash this entire thing. Yeah, we have to encode that. So then we check the hash. And if it's more than that, we put this kind of stuff. So suffix, then hash, and how many leading zeros you have in here, and here's the counter. Okay, so let me, yeah, so we have 4. How quickly does it find the suffix now? So it finds it relatively quickly, right? So it's random stuff. We can even control like how long of the strings it could be. So it's just like from maybe 1 to 100, right? It found something. It found something. So yeah, in 2 seconds. Though when it was like this, it found it faster, I think. It's around 2 seconds, but maybe. Yeah. All right. So what about now 6 zeros? What about 6 zeros? How quickly is it going to find it? So the limit is 2 millions. The limit is 2 millions. 6 is kind of difficult to find. It is true. It is kind of difficult to find. Fascinating. Maybe we should use base 64, chat, by the way. Yeah, I think we should use base 64 because base 64 includes basically everything, all of the different characters and stuff like that. 30 seconds was not enough to find. So it kind of like grows exponentially. It grows like complexity grows really, really fast. So it becomes very, very difficult. All right, so how do you do base 64? Do you just have base 64? You do. All right, so base 64. So functions. So B13. So there's a lot of things. Okay, so I suppose there's like a B64 encode. Right, so random bytes, right? And let's not hex this entire thing. Let's do base 64 B64 encode. Yeah, so this is roughly what we want to be doing. And it gives you, yeah, so base 64 in my opinion is just like better for encoding this entire stuff. From base 64 import B64 encode. B64 not 65, 64 encode. Yeah, so let's start with just 5, how quickly you can find bytes. So encode, bro, can I just convert it to a string? Nah. Yes, probably have to encode or decode. I think it was decode, or maybe it was a str decode. Str decode. Yeah, and you encode. So it was. I forgot. Does anybody remember? Excuse. Okay. Python. What is it? Bytes. String. Didn't code. Yeah, I know. I fucked it up. Yeah, decode UTF-18. Okay, so let me see. So decode UTF-8. Yeah, let's go. Decode UTF-8. Okay, so we're searching 5. Searching 5. That was fast. Damn. Well, I mean, it depends. It actually kind of depends, but base 64 with random, super fast. Because again, like I feel like this is due to usage of all sorts of characters, right? So B64 encode is already bytes. I don't know why. Well, I mean, we have to decode because here we were working with strings, but whatever. So there's a little bit of a weird conversion going on here, so I don't think it's that important. So how quickly can you find 6? It's kind of interesting how quickly it becomes almost impossible. I want it to be close to like a minute. I think something like, there we go, 20 seconds. That is cool. We found 6. So you can also parallelize that, sure. Like you can probably search a lot of stuff in parallel. Okay, so can I increase it further? Like what about 7? Is that a good challenge? Is that a good challenge? 7. If you do rand 300 instead of 100, it will be faster, maybe. I can do that, but I mean, so already we're looking for 7. Okay. Are there access to the conversation on Discord? You have to subscribe on Twitch or on Patreon, or I have to know you personally. I do not know you personally. Couldn't find it. Okay, so let's allocate maybe slightly more. Right, so let's change the threshold. Yeah, I'm doing Erlang today, but I'm temporarily programming in Python just to like estimate how much, like what kind of a challenge do I need to do, because we're developing like a proof of work thing for Erlang. Yeah, I know. So it's a temporary. It's a temporary. Don't worry about it. But honestly, if you parallelize all of that stuff, maybe you can find it a little bit faster. So I don't know. I don't want it to be like super slow or super fast. I have a feeling that just 6 is enough. I have a feeling that 6 is enough. But doesn't Python have a global interpreter lock? So who cares? You can implement that in any language you want. What we're doing in here, we're just estimating things anyway. We're just estimating things anyway. What's the best way to do unique random in parallel? That's a good question. Can you just like use the entropy from the operating system that is collected in def random? Yeah, I have a feeling that maybe 7 is not a good way to do that. I don't think 7 is a good way to do that. It's getting nowhere. Yeah, so it's over 1 minute already, so it's probably pointless. Something like that is a little better. So it takes like 20 seconds, right? So the last time we tried it took 20 seconds to actually find that solution. Which is all right, I guess. Which is all right. We can use CUDA, but I personally never tried it. Yeah, so 7 seconds to find the solution. Right. So I think it's reasonable. And what we're doing here, we're using like a Unix new lines, and in the actual challenge we'll have to use Windows new lines, I think. So which is something that we can do already. So can I exit in here and just print the content? So here's the content. Yeah, so this is the content of the thing. And so as far as now I can just read the lines, and yeah. So they already end with lines like this. Yeah, I'm not really sure. But anyway, this is not something, this is not like I'm going to be using that in production. So this is just a script to estimate things. Let me git ignore all the beam files and some other shit. And let's go back to Erlang. Right, let's go back to Erlang. So the question is, how are we going to compute SHA-256 in Erlang? So as we already know, there is a crypto module in here. Do you have SHA-256? Yeah, you do. So that's kind of cool. So there is a type SHA-2, right? And it is used where? It is used in functions like support and stuff. Okay, so here, there is a hash algorithm, type hash algorithm. And a hash algorithm is used in all sorts of places. So here's the hash info. Okay, so this is kind of cool. You can just directly hash a type, right? So which is a hash algorithm. And you can just provide the data, and data is IO data. So the question is, what is IO data in Erlang? But let me close all of that shit, by the way. I don't think it's useful for anything. Erlang IO data. They have all the SHAs. Yes. So IO data type. It doesn't really tell me right away, but who fucking cares? Okay, so let's go to here. Crypto hash. I wonder if I can take a look at the documentation of this thing. Yeah, I can. So I can inspect documentation directly in Erlang. This is something that I remember. There's a hash algorithm, and yeah. So crypto hash and going to be SHA-256 according to how I understood all that stuff. And now I can put some data in here. Will it give me anything? It gave me this kind of shit. That is very cool. That is very, very cool. So then after that, I should be able to convert all of that. So I should be able to take a binary encode hex. And boom, we got the thing. That's bogus. So, and then it should be easy to count the leading zeros. How can you count the leading zeros? Well, in Haskell there was a function called like take while. I do remember it. You guys remember? So take while. So essentially it accepts a predicate, returning true or false. You can probably match, yeah, so that's one way to do that, I think. So if you expect a certain amount of binaries, right, so you can say 1, 2, 3, 4, 5, 6, right, so, and you can say the rest is binary. The rest is binary, and you can just do that. And obviously it fails, but then, so if I say, okay, so it should start with 3A, and it's totally fine, right? It's totally fine, but then, yeah, it's okay. So that's a cool way to do that, honestly. That's a cool way to do that. It's a cool way to do that. So hash. So what if I have like a bunch of other stuff in here? For example, what if it's a list? So I have foo /r/n, and then something like bar /r/n. Doesn't work this way. Well, I mean, this is because we're matching, but I think overall it does work. So if I'm gonna be concatenating the lines along with the challenge and stuff like that, I think this is the way I want to do that. All right. So let's go back to pastebin. The beam. So yeah, so this is the challenge. You do accept it and you get the ID binary, which is rather interesting, right? So because we want to trim that binary, I think. Or do we want to trim it? I don't know. So it's supposed to be the suffix that you kind of append. Well, and here's the thing. The suffix ends with /r/n, and that's what we expect anyway. So what we can do now, we can probably have lines. So here's the lines. Here is the challenge, but I'm not sure about the /r/n. So let's put it like that in here, /r/n. And then the suffix, which also probably contains /r/n, right? So because it was sent like that. And now we can try to match this entire thing. And if it starts with 1, 2, 3, 4, 5, 6 zeros, and the rest is binary, that means the challenge was successfully accepted. So what we have to do in here is to send to the user sent and close the connection. Send sock. Right, so sent gn TCP, so it's a gn TCP close sock, and something went wrong, but I mean, who cares? Otherwise, we can say challenged failed, and also close. Also return OK. And return OK from this thing and just close this entire stuff. So I don't get it. Why are you not indenting shit properly, so I made a syntactical error somewhere, probably, yeah, so there you go. So you get accepted, we get the suffix, we're not going to trim it or anything like that, you're supposed to only have like one space in here, right, and so we're also supposed to generate like a random ID. Yeah, we can do that. We already have like a something like this. We can use the similar thing. So here is the ID, and we can just send that ID to you. So this is going to be ID/r/n. So, and this is the ID that you're going to be using to get whatever you submitted in here. Right, that's going to be the ID. Right? Rust nested matches. Well, where do you think Rust got this idea from? Where do you think Rust got this idea from? It's got it from all these functional programming languages from before. So that's exactly what happened. Anyways, so yeah, it all compiles. Look at that. All of that compiles. So let's try to do dialyzer and see where it will fail. Okay, so it still fails in here. And I forgot how we, yeah, so essentially the easiest way to do that is something like this. I do agree with you. I do actually agree with you. Yeah, so and all that compiles. So we basically implemented the post flow, believe it or not, chat. We basically implemented the post flow, except saving the lines to the file. We can actually do that. But first of all, let's actually test how it works, right? So where's the Erlang? Let's close that. Let's recompile the entire thing and paste beam start. We're starting the whole thing, and I'm connecting to this entire thing. Okay, so that's pretty cool. Post foo bar buzz submit challenge accepted your mom. Challenge failed, closed, yeah, so that makes sense. So I think one thing I forgot is something like that. So obviously as a human, I won't be able to pass this challenge. So what I'll need to do probably, I'll need to modify my Python script to actually start, you know, trying to fulfill that challenge. So that's what I'll have to do. By the way, I'm not quite sure why does it say challenge with this thing. I don't think it is necessary. I don't think it is necessary. All right. So let me try to do that one more time. So we're starting the whole thing. Post foo bar buzz submit challenge accepted invalid challenge failed. Okay. What are you Erlanging? I'm developing like a pastebin service which works over telnet. You're supposed to like go into the telnet and you're supposed to submit your text in here. Right, but there's additional thing in here is that you have to do proof of work before sending your text. And then like this is the additional prefix that you have to add to your text file, and then you have to find a suffix that creates a SHA-256 that has 6 leading zeros, and then you send this entire thing with accepted, and the server verifies whether it's true or not, whether you actually fulfill the challenge, and it either accepts your request or not. So as of right now, like I can't do that manually. I need to write a script that does all of that for me. Right, I need to write a script. So as we already do have a script. So /n should be referred to as network line ending and /n as host line ending. Probably. So, but the thing is, like we're just collecting lines that we receive, and they already contain /r/n. So when I'm just putting these lines in here, they already /r/end, right? They already are. So I have to put extra effort to un/r/end them. You know what I mean? So, and I don't want to do that, right? It's just like, So let's just assume that it's all /r/n. So it's all /r/n, and it's just like, yeah, whatever. Something like that. Okay, let's go back to our Python script. So what's the title of today's stream? So the title, I think, is Erlang, right? So set title, Erlang and Python, right? So that's what we're doing, Erlang and Python. Okay. I made a joke on Backend being called network byte order. Yeah. So I see what you mean. Yeah. So that's a good joke. That's a good joke. Okay, Python TCP client. How do you do that? Give me the Python TCP script. Realpython.com. DigitalOcean. Fuck DigitalOcean. Fuck DigitalOcean. So is there? Oh my god, is this generated by LLM? This feels like it's generated by LLM. Okay, so there is a module called le socket. So this is probably what we want in here, right? So we want le socket. Okay, import socket, help socket. Okay, functions socket, create new socket. So you can just create socket, create server, creates a TCP socket and binds it. Yeah, so because that's exactly what you want to do. None of that bullshit. None of that bullshit. Okay, so socket. Do you have like a client then? Can you just like a client? No, it doesn't have a client. So you literally have to do that yourself, which is kind of annoying. So basic Python client socket example. Yeah, let's go here. Which, I mean, fine. So this is a server, but I need a client. I guess that's enough. I guess that's a good one. That's a good one. Okay. So I would like to call it maybe just a client. So sock stream, we're connecting to 6969, obviously, right? So, and the first thing I want to do, so I need to get the content, and with the content, I do need to read the lines specifically. I do need to read the lines. Exit 0, and if I print the content, right? So here is the lines, and I need to spend some effort to to remove this thing. I could trim those things, right? So for a line in this line, and it's just like, I don't remember. Is it just trim? Is it just trim? I don't quite remember. So it's a strip, probably strip. Yeah, but that's not a good thing because it may contain additional spaces and stuff like that. So does a strip have any additional parameters? Like, okay, so help strip characters. So, I suppose if I have hello spaces /n, if I strip specifically /n, well, I mean, I have to do something like that. That's already kind of better. Right, that's already kind of better. So this is the content, and yeah, so we can work with that. So, and obviously, since we'll read by lines, it's not going to contain /n in the middle of the line, right? So because that would be a separate line. So that's a good way to do that. I think that's a good way to do that. Okay, so we're connecting to this entire thing, and what we want to send, post /r/n, right? Then for each individual line in content, we're posting that line with /r/n, like that. Then we submitting this line. So just submit /r/n, and we should start reading. So because after submitting, we get the challenge, right? So you can get this kind of stuff. So let's exit around here, and let's do the help on the client. Maybe we can even exit somewhere here, right? So let's not actually connect. Let's not actually connect. Yeah, so that's much better. Now, if I try to do that, so do we have help? So do we have, yeah, you do have receive. That's cool. And if I don't specify the buffer size, I suspect that it will just receive everything. So receive message. Well, I mean, it feels like you have to specify buffer size. Received up to buffer size for optional flags when no data, when the remote. I'm kind of curious. Like, what if I want to receive all of the data? Does it have any information? Man, okay. So let's try to call this entire thing and just print what we've got. And in terms of exit, let's put the exit somewhere here. All right, so I think our server is already working. Yeah, it's already working. So if I do something, yeah, so it's already working. So now if I try to run the script, so what does it do? Send bytes like object is required, but not string. Fair enough. That's cool. All right. And so if since it's a string, can I just do bytes? Right. So I keep forgetting how to convert between bytes and shit. I'm so sorry, Python developers. I know. Yeah. So I don't fucking. I think it's encode, right? So encode. Yeah, encode. I figured it out. Chat, calm down. Chat, calm down. Chat, calm down. Right, let's fucking go. Yeah. What if I put 0 in here? Fuck. Okay, so 100. Ooh, at which point it is an invalid command though. All right, fair enough. So, okay, so it's just waiting though. Python developers rarely convert UTF-8 strings to bytes. Well, I mean, hackers do. I mean, InfoSec people who do information security. And as far as I know, they really like Python because you can work with bytes and stuff. So, yeah. How can I just receive shit? So this is a bit bizarre, right? Like, why? Okay. So it's said, like, where is the invalid command, brovskis? I don't quite. We need to print the invalid command, I think. I think it needs to be logged, otherwise I won't be able to even know, like, what the fuck is going on. So let's do command and IO format. So error invalid command, and let's put this kind of stuff. So yeah, so it probably has to be as a string, but I mean, it could be kind of dangerous to do this kind of stuff. Okay, so now if I do stat, so hopefully it will log all of that things. So Erlang, let's open them side by side. And fucking, okay. Erlang, fuck you, Erlang. Alright. Invalid command post. Bro, fuck you. How post is an invalid command? Is... Bro. Post. Invalid command. So it also... Yeah. It also sends this kind of thing. Maybe in space. I want, yeah, so I just remembered what I wanted to see. Yeah, so this is what we expect in here. Invalid command. Let's post it like that. And then I'm gonna go here. Ooh. Now it... That's a lot of shit. Wait, it didn't send them. Fucking buffered motherfucker. It's buffered. Look at this shit. So that explains. Oh my god. Fuck you. Like I thought it's not. Oh my. Fucking buffering. I didn't ask to buffer any of that. Language for children. Language. Toy scripting language. Fucking toy scripting language. This is what it is. This is what it fucking is. Okay. Fine. Fucking buffering shit. Anyway. So flush. Can I just ask you to the buffer size send? Okay, so do you have interesting flags to not send data string to socket for the option flag? This call repeated until all data is sent. Okay, so Python socket flush. How do I flush this shit? Yeah, Python sockets. I guess you are talking. No shit, Sherlock. Okay. The fact that there is no just like a single line kind of upsets me. Sleep 1. No. When we flash a socket, the data in the like. Okay, what's the function that flashes the socket? Okay, cool. How do you flash it? Okay, cool. I get it. How do you flash it? Cool. Thank you. Thank you so much. How do you flash it? Is there any way? Does anybody fucking know? It's just, okay, yeah, exactly. Flushed. Can I just flush an underlying like file descriptor and whatnot? I think there is a function to flush a socket because it's not really how TCP works. But I mean, like telnet just like sends shit, right? So it sends packets. So I want to be able to do that. Okay, let's take a look at maybe flags or whatnot. So send normal and ancillary data to the socket. Okay. No need to flash emo. I disagree with that. Protocol magic time. Yeah, so maybe we could do the sleep. So Python, yeah, so time sleep. It's not a freaking agree, no need to flash. Well, I mean, I want to receive them as separate things. This is because it's a streaming fucking protocol, right? This is because it's a streaming fucking protocol. And yeah, that's annoying. Maybe we should do that by UDP, but then we won't be able to do the UDP. Yeah. Send does that automatically. In our case, it just concatenated. We send all of that too fast, I suppose. Okay, so Python sleep. Oh fuck. Well, I mean, I hope it found it. So time sleep. So do I have to import time to be able to use sleep? Yeah. Okay. So let's import time. It's time to reinstall Shin. Okay, so one. Is that a? Okay, is that? Okay, so it's taking some time. Okay. Still accumulated all of that shit. Yeah. It's still accumulated all of it. How can I... Do I really have to treat that? You can not use packet line in a socket creation. Can you not use... that's a good point, actually. Pastebin. So main function packet. Ooh. I want to learn more about this stuff. Packet line. Huh. I want to find the explanation of what all of these things mean. So it's basically how it treats the packets. So yeah, Erlang to do buffering lines. Ooh, this is cool. Thank you so much. I didn't know you can do that, bro. That is epic. Thank you. All right. So Erlang. Yeah. Okay. So now, so let's do post foo submit. Accepted your mom. Cool. Now, let's actually exit in here somewhere. Let's not sleep anywhere. Fuck that. And let's do that. Oh! Thank you. Who suggested that? Who suggested that? So who first suggested that packet line? Yeah, Zahatikov. I think you deserve a VIP, my comrade. Опа! Блять. Unable to add VIP. Alright, I'm sorry. I tried. So we ran out of VIPs, but if I had VIPs, I would have given you. Right. Okay. No need. Okay. Fine. So what we want to do is maybe receive the challenge. So can I... So Python strip prefix. How do I strip the prefix? Remove prefix. Okay. So that makes sense. Remove prefix, and it's gonna be something like that. Challenge. Strip. We got the challenge. So what if this thing doesn't have anything? Yeah, it just doesn't strip it. Okay, in this case, this is like a slop script, so maybe it doesn't matter. So here's the challenge, right? So here's the challenge, and what we're gonna be doing. So we have content, right? So I suppose I wanna join this kind of stuff. Is this how we do that? I think this is how we do that. Yeah. So we have a content /r/end and just join this content plus, and yeah, so it should not contain that, plus the challenge plus /r/n, and then the suffix plus /r/n. So that's how we're going to be going about that. So we might as well actually like append. Can I just do challenge suffix? Is this a divine intellect, chat? No, it isn't, because you also have to add the last one at the end. The last one at the end. which means that probably, yeah, you wanna, maybe I could put like empty line in here. So because if here I have an empty line, yeah, it does additional things. So this is basically what we expect in here, right? So it's the content and plus challenge, suffix, and like the last line. So then we do the hash and we try to find hash. And we try different suffixes in here. And then we find it. So let's go ahead and just try to do that. Exit. We don't exit anywhere. So obviously we don't send anything yet. So what do we want? What do we want? Expected instance byte found. Who's the byte? So, and then was decode, right? So UTF-8. I forgot what was the decode. I saw that. I saw. Yeah, decode UTF-8. Let's fucking go. Is it going to work? Is it going to work? Hopefully it's going to work. Please, please work. So it's Erlang. So the last time I think it was like a 20 or 30 seconds or something like that. You know what? Yeah, session failed obviously, but that's fine. Let's print always. Let's print always so we can see like that it's doing something, because right now it's kind of difficult to. Oh shit. Okay. So yeah, it's trying too much. It is trying too much, but I think it's getting there. I think it's getting there. So it's basically trying all of these different suffixes and stuff like that. All right, so that was a bad idea. Let's not do that. All right. Bitrate goes brrr, brrr. You know what? So limit. I just want to be able to see that the progress is going. That's the only thing I want to have. So let's do some shit like /r, and this is going to be f string, obviously, right? So something like that. So it's a counter limit. Just show me the progress, bro. It's a kind of a sucky-wacky progress, in my opinion. Yeah. So it's supposed to. Fuck. Fuck that then. So I'm gonna be running it from here. Alright, so I'm gonna be running it from here. Time Python 3. Yeah, so at least there is some progress. At least there is some progress. So here's Erlang. Did it ever connect it? Because I didn't see a connection. So it doesn't find anything, surprisingly. Is it not gonna find? Bro. Well, okay. The last time it was 20 seconds, right? So maybe I just have to be patient. I don't know why I'm so impatient right now. So yeah, let's just trust in process. Prints are slow, yeah. So I'm gonna put like a soon in here just to have a like rough estimation how much time has passed. And yeah, so it's roughly 20 seconds, 30 seconds or whatnot. Tea break ideal time, maybe, I don't know. Oh shit, it found it. Fuck yeah. Alright, so let's fucking go. So what we're gonna do in here, so accept it, and this is the suffix, and suffix is actually, well, you know what, how do we use the suffix? Let's decode the suffix in here, but encode the suffix, but use the suffix like that in here. /r/n b. because it's bytes and we're sending this entire thing, then we probably want to receive some shit in here, which we want to print. Like we want to like see the response from the user. Okay, let's fucking go. So I'm gonna restart the soon. So it's roughly 20 seconds. It's usually roughly 20 seconds, which is a good time, I think. Which is a good time. Challenge failed. Fuck yeah. Challenge failed. I wonder why though. So okay, this is the suffix we found. So C4. No, it's not C4. It has to be 6. Okay, let's go back to pastebin. Let's go back to pastebin. Honestly, my goal was to explore proof of work. Right. If we manage this particular aspect of the application work, I'm gonna call the goal of today's stream achieved, because then the rest of the stuff and hosting it somewhere, it's just a routine work. It could be done like a little bit later. So this is kind of the core of the thing I'm trying to explore. And if I manage to make it work, well, yeah, so that basically works. So just use the Anubis Beam module. Does it even exist? I don't know. So here's the 6 of these things, and I want to see what this thing is equal to. Challenge failed. So let's see. So this is hash, and I can do format error challenge failed, and let's actually take a look at the hash that we get from here. Let's literally log all of that. And don't forget about that. All right, so I'm gonna kill that stuff, and I'm gonna restart the whole thing. Boom, and let's go back to this thing. All right, hopefully we connected. So yeah, it's a proof of work for pastebin-like service, which is not over HTTP, it's over telnet. So, which is kind of interesting, I think. So if I manage to make this aspect of this application work on today's stream, I think I'm gonna finish the rest of the stuff off screen, or maybe do like a footprint, like footnote, and then I'm gonna just deploy it on your mom, so anybody can try to play with this service. Right, that's gonna be the idea. I feel like I might be actually just concatenating things in a not correct way. That's what could be happening in here. Can somebody explain the challenge yourself? It's called hash cache, I think. So we're using hash cache. So you can check it out in here. So the idea is that you're trying to find like a suffix for a certain data so that the hash starts with zeros. Okay, so something, yeah, the hash is weird, as you can see in here. The hash is straight up weird. So I do not know what's up with that. It took a minute, by the way. This one took a minute. So also maybe it makes sense to print like that. So let's start beam. Maybe, okay, so let's actually simplify the challenge. What if we, not 6, but 5? Let's actually make it like that so it's clear. Not 6, but 5. That also means that here we're going to be expecting this, because it's too long. Alright, so it's too long to wait. So... let's go. I should have had some sort of a logging. Okay, so yeah, clearly something is wrong. Like we found it, we kind of found it, but then the hash itself is completely freaking different. Completely freaking different. So I need to double check in both of the script and the server how we concatenate things. So the content, I remove /n's. That is totally understandable. Right, so then I send all of these things. Okay, so let's print s. But I want to print it as bytes, so I want to encode. Yeah. So foo bar bus slash, all of that is /r/n. All of that /r/n, especially this thing. Okay. So then the suffix and yeah, so all of that is as I expected. All of that is how I expect all this stuff. So now here, lines. So this could be, yeah, this could be weird. Maybe suffix. I need to print this thing. Let's call it blob. Ion format blob. Blob. Okay, so think. Oh yeah, of course. I have to get rid of the stop gap that I put in here. Where's my compilation mode? Yeah. Did I not recompile? Where is the blob? That's bizarre. I forgot to recompile. Oh, it doesn't even compile. Why the fuck just happened? How did I end up with like that? So there's a syntactic. Did I? No, this is not that. Where did I introduce syntactical error? What the fuck? Wait a second. Doesn't make any sense. Where is the syntactical error? No, there's a syntactical error. Format is a semantical error. Fuck, I introduced some syntactic error somewhere. I didn't see it. Encode hex missing a parent. Encode hex. Oh yeah. Okay, thank you. Fuck, I hate this language. Holy fuck. All right, so blob. Format. Blob. All right, let's go. So let's fucking go. Okay, so we got something, and of course it's fucking IO format that it. This is so annoying. Like, can you put some sort of type spec so you can catch such a common fucking mistakes? It's like I don't. Well, and it's funny is that this is also list. Like IO format is the dumbest function I've ever seen in any fucking language. Honestly, it's the dumbest function. Like, holy fuck, I hate it. I hate this function. So whoever come up with this function, you do realize how many human years you've stolen from the humanity. Not that many, because nobody uses this language. All right, anyway. So let's fucking go. Yes. All right, challenge failed. And yep. Okay, so this is a, okay, so we have /r/n, that's understandable. At the end of that stuff, so where is the, wait, well, okay. Did it not properly concatenate all of that stuff? Like, I have a strange feeling that it simply didn't concatenate. Maybe it's too freaking nested. Maybe that's what happened. It's kind of difficult to tell, right? So it's kind of difficult to tell, right? So Erlang concat binaries. How do we concatenate binaries in Erlang? Well, yeah, so you have a bunch of binaries, and you just do that. But do you have to put a slash in here? This is kind of a good question. So let me copy paste these two things. Let me copy paste these two things. Why did you copy paste in here, you stupid ass Emacs? Okay, so if I do B1 and B2, yeah, you have to explicitly say that they are binaries. Yeah. Yeah, that's how you do that. But if I have a but I have a list of binaries, like join list of binaries. I have something like that. I'm joining a list of some weird ass LLM website, of course. No, fuck no, I'm not doing that. Fuck you. There should be a standard function to do that. Can you sum enum join? Maybe, I don't fucking know. And there's like, what is dot? There's no such thing in here. And this is annoying because like I don't know how exactly the encoder going to interpret this thing. Maybe join beans while joining the line. Yeah, probably that's what I have to do. So yeah. So where is the lines? Okay, so here is the list of and the challenge. If we do the challenge, all of that is lines. Yeah, let's keep them binaries. That's a good idea. I kind of like it. That's a good idea. All right, so now what I have to do is dialyzer. Let's do dialyzer and go through the compilation errors. I think. So when we switch into post, let's make it like an empty thing. All right. So this one, so we got the lines, and the way we can do that, so we have the lines binary and the line binary. Hopefully that will work. So yeah, it should work, right? So because this thing is a binary, so we're just like accumulating all that stuff, and it was successful. Okay, when I'm verifying this entire stuff, so here's the lines. So we have a blob, which means that we can do binary challenge binary, and this one I'm not quite sure. Do we have to also do binary? So let's see if the dialyzer is going to complain about this thing. Hell yeah, it doesn't complain. Oh boy. Okay, so challenge failed, and it's going to print the hash, which is good. So I hope we're using the correct hash. So we're using SHA-256. That's what we're doing, and in the paste in here we'll also use SHA-256. Okay, so double checked pretty much everything. Let's kill that. It complains about something. Binary will fail because of the type mismatch, but dialyzer said it's fine. What the fuck are you saying? Do I have to say something like this? Okay, sure. And let's double check dialyzer then, if it's complaining about this thing. This type thing fuckery is too close to my work, yeah. So we're doing real work, real software development in here, by the way. People say I don't do real software development, so there you go. Here's the real software development for you. Okay, so let's fucking go. It's taking too long, honestly. It succeeded. I think it succeeded. Chat. We got back the ID. Hell yeah. So absolute trading, absolute fucking trading. To actually confirm that, I think what we have to say is, so we're just sending back ID. We're just sending back ID. What we have to be sending is sent space ID and so on and so forth. So let me just remove that. I'm removing that. Beam. Bro, Erlang. Let's compile that, start that, go to the compilation. So it's taking some time. Sent plus ID. So we successfully implemented the proof of work, right? So it's impossible to just send anything without this kind of proof of work, right? So you have to spend a little bit of CPU to do that. So we can do a little bit more difficult proof of work, which is six shut up, which is 6 zeros. All right, so let's put 6 zeros in here and let's freaking do that. Right, so remove that. And compile, boom, let's fucking go. So it's gonna take a little bit more time, right? So, but I think it's worth testing. So we also need to put some sort of a timeout on waiting for the challenge. Bro, why don't you just get a US degree and get a job at FANG to piss you off? Alright. Hell yeah. Hell fucking yeah. So we send this entire thing. That's so fucking cool. That's so fucking cool. So the next step is actually taking the content and saving the content to a file. Right, so then it can be requested. How easy or difficult it is to just save that file? Like, we have ID. What you just have to do, you have to create a file with that ID. Right. So, yeah. Erlang save to file. I think it uses the awful stream-oriented API. It doesn't have just save text to file, right? So save text to file. That's what I want to be able to do. Erlang values to file and loading. Binary to term. Oh, holy fuck! It just has a write file? Are you fucking serious, my friend? What the fuck, bruv-skis? Oh, oh, oh. Oh, it even accepts motherfucking bytes. Okay, that's cool. We're gonna be using that shit. So, all right. So here's that, but you have to convert that to a string. So can I just use ID like directly in here? And the content is gonna be just the lines. All right, so it may actually fail, but I don't give a shit. I actually don't give a shit. So here is the challenge TXT. So we need some text. B script TXT. Oh, what's funny is that this has a very cool side effect, chat. This entire challenge. The longer text you want to send, the longer it will take for you to compute the hash. Because text is part of the challenge. This is cool. Honestly, I kind of didn't expect that. So you can't really make it too long. Right. So you can't really make it too long. Yeah. wget. Line detecting IO data, so it might be fine when writing. I don't know what is an IO data. I see. So how big of a file this is? 2000 lines of code. Is that big? Is that too much? Maybe. You need to use prefix for that to be true. With suffix, you can pre-compute it. Ah, that is true. Ping Joshi, you're a genius. You probably work in crypto or something. Yeah, you're right. So we'll have to do that. But I think I'm gonna do that as a separate to-do. So use prefix challenge instead of suffix. It's a good one. If I had additional VIPs, I would have given you VIP. You see, I'm not a crypto person, so I do not know this kind of nuance. No. All right, so I think we're almost there, right? So if we just like save that. Okay, so bmovie script. Can I send bmovie script? Is it gonna be too much to send? Gonna be too much. Probably it's gonna be too much to send. So let's reduce the challenge. Maybe amount of zeros is gonna be part of the challenge. So I remember that some of the systems actually tell you the amount of zeros and also some sort of a hash, right? So it's kind of dynamic. It's not hard-coded like that. So we can do a similar thing. So there's going to be 5 zeros in here, and so 5 zeros and 5 zeros in here. Okay, so it does compile, but let's actually do dialyzer. The dialyzer is happy. Happy, happy, happy. Cool. Yeah, let's start and let's fucking go. I wonder if it's going to be fast enough. Log payload size. Okay. Which is not that much, honestly. Miner, yeah, we're mining. Oh, fuck. Oh, shit. It prints. I forgot that it tries to print the content when it succeeds. Fuck. We successfully saved it. So now, what you have to do, right, so is implement get that given the name of this file gets you the content of the file. Obviously, don't forget to sanitize the input and do not allow any slashes in the ID. Okay? Otherwise, the user will be able to do shit like, I don't fucking know, like etc. Well, you know what I mean, right? So it's just like do not allow any slashes and stuff like that. Yeah, so get pastebin here. So, but that's basically it, right? Isn't it? So we basically implemented a proof of work. That's so cool, right? So now I know how to implement it, and just like, yeah. So my plan is I'm gonna clean it up, finish it all up, and then I'm gonna, before even uploading this vote to YouTube, I'm gonna also deploy this entire thing to your mom, which is our server. So then the viewers can just like play with that system, right? So send some files and whatnot. That's gonna be the plan. So because I think I achieved the core goal of today's stream, which is proof of work, right? I think we did it, right? That's so cool. That is actually super cool. So yeah, I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Thank you for all the subs, resubs, recommitments, and I see you all on the next recreation programming session with Mr. Azozin, where we're gonna do even more absolute codings. I love you all. Mwah.